Data visualization is the display of information using standard images such as chart, plot, infographic, and even animation. These information visualizations simplify complex data interaction and data-driven insights. Through this course, we will learn about the many Python libraries such as Matplotlib, Seaborn, and Plotlib, as well as data visualization tools such as Tableau and PowerBi. These libraries are mostly used in effective presentation of data using data visualization. This video includes an overview of several ideas as well as a hands-on demonstration using Python programming language. So without any further ado, let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments. Now, very quickly, let me walk you through the agenda for this course. In today's course, we are going to discuss data visualization using Python, Python Matplotlib, Python Seaborn, Plotlib Python, Tableau, and PowerBi.
Let us now go ahead and talk about data visualization. Well, talking about data visualization lies at the heart of these 3 pointers that you see at the 3 corners of the slide, right? Design, information science, and communication. Now, basically, when you talk about data visualization, it is nothing but the ability for you to go ahead and present your data in more visual form, right? So that is what data visualization is, right? And why do we do that? Well, to start with, let's assume that I give you a data which has maybe 20,000 records, right? And it has like 175 attributes. And I just ask you to go ahead and give me insights from this data. I tell you that, okay, help me find particular set of information. Tell me the sales. What is the average sales? So if I have to, I'll have to basically go ahead and average these 10,000 records, right? So that would be a tedious task. And this is an easier problem statement that I put forth. The fact that I've mentioned that there could be 150, 170, 200 attributes. Finding out relationships between these attributes could be even more difficult, right? So what I'm trying to emphasize here is if I give you data in more textual form, in more numerical form, it would be difficult for you to go ahead and understand. What if I just go ahead and draw a chart giving you a profit or giving you major numbers? Right? Wouldn't that be easier for you to understand, right? That is how data works. That is how information works. They say a picture is worth 1,000 words or 100 words. I don't know what that saying is, but that is very true, right? In kids' books, we have images. Why? Because they basically can relate to those quicker than to go ahead and read the text. Because our mind gets stimulated more by visual stuff. If we see something, we try to understand that better. To give you another example, even in childhood, when you talk about kids, when we teach them square, circle, rectangle, right? These are shapes and they have colors. And if they do, children can relate to it. What is green? What is square, right? So that is where data visualization comes into picture, right? If you can basically create visuals out of the data that you have, it would be easier for you to understand. And that is what data visualization does for you. Another example here would be, let's assume that you want to read a notebook, or not a notebook, a novel would be a better word. So if you are to read a novel, what you would do is you'd actually go ahead and start reading it. And even if you are a very good reader, avid reader, if you're reading like a 700 page size book, it would at least take you a couple of days, 2-3 days at least, right? Even if you're an avid reader, because that is how much a human can read in a day. Right? Let's assume that you are a slow reader. It could take more time for you, right? A week or 2. What if I create a movie on that book? I'm sure that you can watch that movie in 2 hours, or even if it is something like Lord of Rings, it would be like 3.5 hours to 4 hours, right? So given the fact that you've watched a movie for 4 hours, you can actually grasp what that book has to tell you in like what, few hours, and you would at least get 80% of what that book has to offer to you, even though if they cut down on certain details. The difference here is when you write a novel, you basically are explaining a particular individual, right? If you're talking about maybe the main character of the book, the lead of the book, you'd probably spend a page and a half to describe how that individual is, or a couple of paragraphs. But when you talk about it from a visual perspective, you dress that character like that, make up that character like that, and you would see, you won't have to spend too much time doing that, right? Within a split second, you'd understand what kind of clothes this person has worn, right? So that is what data visualization does. When you have a lot of information, data visualization simplifies it down into simpler or more manageable information by giving you it in a visual form, right? So it is at the intersection of design, communication, and information science. Now, what do I mean by this? Now, when you say that it is at an intersection of all these, what that means is basically you have data with you, your information science, right? You basically use it to create a particular design that would communicate a particular message. In this case, a business goal, a business insight, right? So that is what data visualization is. And if you people are thinking that data visualization is new and it is something that has come up recently, or it is something that has come up like yesterday, let me warn you, that is not true. It is not something that has come up yesterday in last half a decade or something like that. It has been there for a very long time. Yes, due to the increase in the amount of data that we use these days, right, its importance has increased. But if you talk about its initiation, it started very early, and one of the first records that data science or data visualization was used, please forgive me if I've used data science in the past, it's data visualization. So the fact that data visualization, if you track its initial traces, you'd realize that it was 1781 that William Playfair used it to basically explore the exports from 17 different countries to Scotland, and he used geometric charts to do that in 1781, and that is like more than a couple of centuries back, right? So it has been there. People have been using visual explanations, presentations to explain the idea, and these days its importance has fairly increased, and there are reasons for it, right? So as I've mentioned, I mean, the influx in data science or the increase in data science happened like 12 years from now. If we go back, this is where we started using the Android phones, started using all the internet and digital data that we had. There was a huge surge in the number of people using Instagram, Facebook, and the major contribution to that was done by India. In 2015, 2016, when Jio was launched in February, they offered free internet services for 6 months for people to use on their mobile phones. What that meant was we saw a huge increase in the people using Facebook, Instagram, and other social media platforms in India. And this is where this revolution started. And that is why the amount of digital data that was being generated by India alone was huge, and it contributed to the world. And no wonder that the other world has also developed. I have nothing against it. They have been using digital data for a very long time, but India precisely started it in this phase, and this is where the boom happened, given the fact that the huge amount of population that India offers, right? And that is why we see importance of digital data that we have, and that is why we see all the more importance being given to data visualization, which has been there since long. But nowadays we crave for data, and we basically understand its importance a lot more, given the fact that it helps pave so many decisions that we take. So that is what business intelligence and data visualization is in a nutshell, right? If we are to talk about business intelligence and data visualization phases, there's one pointer that I've missed out on. I would like to brief on that first, right? So if we are to talk about those first, basically these tools or the process of business intelligence has changed with time. when you talk about initial phases, we had the developer phase where we needed technical people for us to go ahead and visualize our data, right? But as time changed, that changed too, right? If you talk about like 15 years from now, we had analysts and tools that could support getting in this data, and even the analysts could process to do this data to basically go ahead and do mathematical operations on top of it and use it for visualization, right? And as we progressed, we came into the world where we had tools like Tableau, Power BI, even Excel to a very great extent, then ClickSense, ClickView, using which we could actually go ahead and visualize this data in a very different manner and with a lot of ease. There were no technical dependencies here, no analysts dependencies here. When we actually go ahead and take a look at the practical part of this course, you'd understand how easy it is to visualize data using something like data visualization, right? Or tool like Tableau or Power BI rather. So that is what has changed with time, and this is how the phases of data visualization have also evolved. So this is what data visualization is in a nutshell. I hope that you people have understood what it is. Let us now go ahead and take a look at the next point. So if we talk about data visualization tools, we have plenty of data visualization tools in the market. You have Tableau, you have Power BI, you have Excel, as you can see on the screen, you have ClickSense, you have ClickView. So there are quite a few data visualization tools that are there in the market, which are very popular. One of the leading ones though are these that you see, right? So let's try and understand them one by one, right? So one of the leaders in the market right now is Tableau. That is not questionable. It had a huge head start and was one of the leaders when you talk about the current market, but it was closely followed by Power BI, and Power BI has covered a lot of gap between the two. So now both of these are fairly close to each other. I mean, if you talk about the comparison, and if you want to compare them, there's something called as Gartner's chart, Gartner's quadrant, that helps you compare business intelligence tools. And if you take a look at them in that quadrant, you'd realize that they're very close to each other. I had checked it a year back. Right now I'm not very updated with the numbers, but I'm not sure whether Power BI overtook it, but at that pace it was going really good at that time, and I thought that it would be soon that Power BI might overtake Tableau. But Tableau was the leader then a year back, and it's still I expect it to be. So both of them are fairly good tools, right? When you talk about Tableau in particular, it was launched in May 2013, okay? And basically it is a product that basically meant we could actually go ahead and visualize our data with a lot more ease. Now when you talk about Tableau, it offers you quite a few features, like the smoothness of visualization that you get is immense, right? There are quite a few good analysis capabilities that it offers, and the other part is it is an end-to-end tool. Now what that means is basically when you talk about it from an analytics perspective, it supports quite a few features that make it end-to-end. You won't be needing anything else to do some of the activities that are there. Same is with Power BI, highly effective tool. It is a Microsoft product, right? So readily integrates with all the Microsoft stack of products, and basically offers you quite a lot of visualizations. When you talk about the options, when it gives you in terms of visualization, they are huge. If you talk about its launch date, it was launched in 2014, and it's again a very effective and a very good tool. Similarly, you have something called as Excel. I'm sure that all of you know what Excel is, and to be very frank, you might be surprised when you find it on this sheet, but or on this presentation rather. But Excel is a very effective tool. We all have been using Excel, might not for data visualization, but it can give you quite a few good visualizations. And apart from that, the fact is it readily integrates with tools like Tableau, Power BI, making it a perennial tool for everybody to use, right? And then there are other tools like you have your ClickView, you have your ClickSense, right? So when you talk about ClickView, it again is a tool that basically lets you visualize your data and gives you quite a few visualization, right? So it is called as a tool for the modern analytics, and it supports a lot of analytics features, right? If you talk about basically having some augmented intelligence or dealing with data that supports multi-clouds, right? So this is where ClickSense Analytics platform comes into picture. So it is more of an analytics platform that supports data visualization. There would be some of you who might question as in, aren't Python and R good for visualization? I often get these questions in my classes, in my sessions that I take. So to answer your question, yes. When you talk about R and Python, these are tools that do help you do visualization, but these are end user tools that you see on the screen. If you talk about Python and R, those are programming languages. So you can program visualizations out of it. So you'll have to write pieces of code for it. When you talk about Tableau, PowerBi, ClickSense, ClickView, Excel to some extent, you don't have to basically go ahead and query your data. You can just put that data there and just visualize it with a lot more ease. So these are some of the popular data visualization tools.
Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. Bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys. And I'll go ahead and convert these keys into a list. So I'll pass this into this list method and I'll store the result in this names object. Similarly, I'll extract all of the values. I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values. The second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names, and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now, the plot which we had created earlier was very bland, and we can go ahead and add the title, X label, and Y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the X label and the Y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names on the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true. So it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. We can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar, and we are adding a color as well. So by default we had the blue color, and if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis we'll have names. Let me change this to names, and as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities, and these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in x, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have y, and in y I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x comma y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same x and a. These are the same lists which we have. It's just that we are adding new attributes over here. The first attribute is marker. initially we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot where we had two lines in the same graph, we can perform a similar sort of thing over here where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. And I'm not adding the marker because we have already added the marker for the first one. I'll just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters, and since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1. And the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt.subplot, and here I'll be writing 1, 2, 2. And this is our first subplot, and this is our second subplot. histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1. And I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show, and this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4. And this is the result which I get. I'll copy this entire thing. I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv since this is a CSV file. So inside read_csv, I am passing in the name of the file and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column and I'll set the number of bins and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd. And we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame. And as we see, we have sepal length, sepal width, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll given the name of the column. So the name of the column, let me keep this to be small, it'll be petal length, and I'll set the number of bins to be equal to, let's say 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list. And I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot. And inside this, I'm passing in this data object which I just created. And when I show it out, this is the result which I get. Now, when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list, the minimum value will be 4, the maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1, and inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly given 9 numbers. And again, I'll have L3, and also in L3, I'll just randomly given some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these 3 box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5. The minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the violin plot. So the only difference is to create a violin plot, we'll be using violin plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.violinplot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have two lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie, and here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create two lists over here. I'll create the first list. I'll have fruit, and the first fruit will be apple. The second fruit will be mango. The third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples. I've got 43 mangoes. I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to give in the categorical object. So I'm mapping fruit onto the labels. Then I would just have to show out this pie chart. So plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here, for this auto PCT attribute, I am using 0.1f. Now, what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here I'll have to use %0.1f. Let me add %. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. And something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entities. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5. It is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4. The radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually. And let me keep this as 1. And this is the resultant donut chart. So Seaborn is another visualization library which is built on top of Matplotlib. So if you want to work with Seaborn, then we'd have to import Matplotlib as well. So to import Seaborn, we'd have to type in import Seaborn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside Seaborn, we have this method called as load dataset, and we have some built-in datasets inside the Seaborn library. And one such built-in dataset is the fMRI dataset, and I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this Seaborn library, since I've given the alias for this Seaborn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset, that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing, and after 10 seconds, this sort of stabilizes and only increases to. So here, if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to Seaborn. Let me rename it. I'll delete this. I'll name this as Seaborn Demo. And we'd have to load the required libraries. The first library is obviously Seaborn. So I'll have import Seaborn as SNS. Then I'd also need pipeplot. So I'll have from Matplotlib import pipeplot as PLT. Let's just wait for these two libraries to load. And once we have Seaborn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have SNS dot load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI. And I will store it in this object called as fMRI, and let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present, and I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. SNS dot line plot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event, and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2. And when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. And also if you see the increase of it, so once it dropped, the increase of queue event is much higher when compared to the increase of this stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, So seems like we have an error again over here. I have 2 commas. Let me go ahead and delete this comma. And we have successfully produced these 2 line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line, and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. Now we'll go ahead and create a bar plot with the Seaborn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have 2 categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need pandas. So I'll just type in import pandas as PD. Now, once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this, I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this isLegendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this isLegendary column and then the speed column. So I'll be using sns.barplot, and onto the x-axis, I would have to map isLegendary, and then onto the y-axis, I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon dataset. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between isLegendary column and weight in kg column. So isLegendary column is again mapped onto the x-axis. It's just that here for the y-axis, we are mapping weight kg column. And this time it is very, very obvious that legendary Pokemons, their weight is much, much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column, and we already know to do that we'll be using the hue aesthetic or the hue attribute, and I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary. This denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plotter is between is legendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette, and we can directly use different predefined palettes. So first we have the Blues D palette with a capital B. This is how it looks like. Then we have the Rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is Blues D. And as you guys see, this is the Blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the Rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG, and this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette, I'll have the color attribute, and I will set the color of these 2 bars to be equal to orange. And this is the result. Scatter plot, and we have already learned that a scatter plot is used to understand the relationship between 2 numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up. Then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatterplot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got three different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the virginica species. Similarly, we've got three different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add two more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. And now let's say instead of having the colors to be determined by a categorical column, if I actually want the color to be determined by a numerical column, I can also do that. So here, since petal length is mapped on the y-axis and I want the color to be with respect to the petal length, I'll go ahead and map the petal length onto the hue aesthetic. And as you guys see over here, as the value of petal length is increasing, the intensity of these points is also increasing. So here on this lower left side over here, we have all of this very light shaded circles. And at the top right, you have this high intensity or high intensely colored circles over here. I'll copy this. I'll paste it over here. Now, I'll want the hue or the color to be actually determined by petal length itself. Let me keep the L to be capital. And when I hit on run, you would see that as the petal length value increases, the intensity of the color also increases. Let me just go ahead and also add the style over here. So this time the style will be determined by the species column. And you would see that we have three different styles. For Setosa, this is Setosa, you have solid circles. For versicolor, you have crosses. And for virginica, you have solid squares. Now we'll go ahead and make a histogram or a distribution plot. So a distribution plot, you can consider this to be a combination of a frequency curve and a histogram. And we've already worked with histogram when it came to Matplotlib. We know that a histogram is used to understand the distribution of a continuous numerical value. So for this, we'll be using the diamonds data frame. So we'll load up this diamonds data frame, we'll store it in this diamonds object, and then we'll have a glance at it. After that, to create this distribution plot, we'll use dist plot, and inside this, if I want to understand the distribution of the price column, I'll just pass it over here. So I'll have diamonds of price, and as you guys see, this would show us the distribution plot. And as I've told you, the distribution plot is a combination of a histogram and the frequency curve over here. I'll just add this comment and I'll add distribution plot. Now over here, to create this distribution plot, I would need to load up the diamonds data set. So I'll have pd.read_csv, and inside this I'll be passing in the diamonds.csv file, and I will store it in this new object called as diamond. Now that I've loaded this data set, let me have a glance at the first 5 records of this. So diamond.head, and these are the different columns which are present. So I've got caret, which obviously tells us about the caret of the diamond. Then we've got the cut type of the diamond. We've got color, clarity, depth, table, price. So this is price of the diamond in US dollars. So the price would mostly range from around $300 to around $18,000. Then we've got X, Y, and Z. X over here denotes the length of the diamond in millimeters, Y denotes the width of the diamond in millimeters, and Z denotes the depth of the diamond in millimeters. So once this is clear, I'd have to make a distribution plot, and since distribution plot is used for continuous numerical values, I'd want to make a distribution plot for this particular column. So I'll have sns.distplot, and inside this I'll be passing in diamond. I'll have square braces over here. Inside this I'd have to pass in the column which is price, and I would just show this out. I'll have plt.show, and you would see that I have created this distribution plot over here. Now in the distribution plot, let's say if I want only the frequency curve without the histogram, that also can be done. It's just that in the same command, I would have to set hist to be equal to false. And when I set hist to be equal to false, I'll only get the frequency curve. I'll copy it, I'll paste it over here, and I'll add a new attribute called as hist, and I'll set this to be equal to false. And when that is done, you would see the difference. So this was a distribution plot which had both histogram and the frequency curve. Now this is a distribution plot which comprises of only the frequency curve. Now similarly, we can go ahead and add a new color to this, and to add a new color, we'll just use this color attribute and add this. So this was the distribution plot which we had created. And to this, if I want to add color, I'll use this color attribute. I'll assign it red, and you would see that I have assigned it the red color. Now, if I want a distribution plot without the frequency curve, which would mean I'd want only the histogram, then here I will set KDE equal to false. So in the distribution plot, either we can have both the histogram as well as the frequency curve, or we can just have the histogram, or we can just have the frequency curve. To just get the frequency curve, we'll set hist to be false. To just get the histogram, we'll set KDE to be equal to false. And we can also go ahead and vary the number of bins which are present. To vary the number of bins, I'll use this attribute called as bins, and over here I'm setting the number of bins to be equal to 10, and I'm just setting the color to be equal to green. I'll select this over here, I'll paste it, and I'll set KDE to be equal to false. And when I do this, you would see that I have only the histogram without the frequency curve. Now, if I want to change the number of bins which are present, so since there are 150 records, I'll have 150 bins, but instead of having all of this, so let's say if I want only 50 odd bins over here, I'll set 50. And as you guys see, I have only 50 bins. Now, let's say instead of 50, maybe if I want only 10 bins. So you will see that I have only 10 bins. Now, let's say if I want only 5, that also something which can be done. I'll set the value to be equal to 5, and we have only 5 bins over here. And after this, let's say if I want to plot it on a different axis. So till now, we've been creating this distribution plot where on the x-axis, or basically this was based on the x-axis, but instead of having it to be based on the x-axis, if I want to map it vertically, then I would just have to set vertical to be equal to true. I'll have the same command over here, and here I'll set vertical to be equal to true. I'll remove this KDE equal to false from this. I'll also remove this particular attribute from this. Now, if I hit on run, you would see that I have mapped this distribution plot onto the y-axis. Next, we have a new geometry called as a joint plot. So this joint plot is a combination of a scatter plot and a histogram. So as you guys see over here, I have a scatter plot in the center and I have a histogram at the top side and the right side. And I'll be creating this joint plot on top of this iris data frame. So once I've loaded this iris data frame, I want to create a joint plot between sepal length and petal length. So I just created a scatter plot. So for scatter plot, we are just use scatter plot method. For joint plot, it's just that we have to use this particular method. We are passing in the same columns. Now, when it came to scatter plot, we had only this particular part. But when it comes to joint plot, here what you see for sepal length, you would have the histogram of the sepal length column as well. Similarly, for petal length, you will have the histogram for petal length column as well. So this is an interesting point about joint plot. We already have loaded the iris data frame. Now, I'll have to use sns.jointplot, and onto the x-axis I'll be mapping sepal.length, and onto the y-axis I'd have to map something. So onto the y-axis I'll be mapping petal.length, and that is pretty much it. I'd actually have to give in the data as well. So the data on which I'm making this is the iris data set. Then here I'll have plt.show, and when I hit on run, so seems like we have an error over here. So sepal length, so L has to be capital. Let me make it capital L. And you would see that I have successfully created this joint plot where I have the scatter plot in the center and I have corresponding histogram for sepal length on the top, corresponding histogram for petal length on the right side. And over here, if I want to change the color, that is also something which can be done, and we've already seen this throughout. So all I have to do is use this color attribute, and I have to give in a color for this. And if I like the olive color, that is what I'll be going ahead and mapping it onto this attribute. I'll add this color attribute and I'll have olive. And as you guys see, I have mapped the olive color for this joint plot. Now for this, if I want a regression line through the scatter plot and also through the histogram, I'd have to use this new attribute called as kind. And for this new attribute kind, I am assigning this value reg. So as you guys see, I have this regression line which is passing through the sepal length values and the petal length values. And also it is passing through both of these histograms. So here I'll have kind and I'll have the value reg set for this kind attribute. Let's wait for the result, and you would see that I have added a regression line which goes through the histogram and also goes through the scatter plot. Let's go ahead to the next geometry, which is a box plot. And to create a box plot, we'll just be using this box plot method, and we'll be creating this box plot on top of the churn data frame. So we'd have to load this data frame first. So this data frame tells us about the different features of a telecom company. And on the basis of this features, we'd have to find out if the customer will churn out or will stick to the same company. So here we have the churn column and the tenure column. The churn column I'm mapping onto the x-axis, the tenure column I'm mapping onto the y-axis, and obviously I'm building this box plot on top of the churn data frame. One interesting attribute about a box plot is that box plot can be mostly used to understand how does a categorical value change along with a numerical value. So that is why here we have mapped this categorical column churn onto the x-axis and this numerical column tenure onto the y-axis. And we see that, so this what you see is the median value which we have already seen. So when it comes to people who do not churn out, it seems that those people who do not churn out, their median tenure or their tenure in general is longer than those people who actually churn out. So I would have to load this data frame first. I would have to store it in this churn object. So churn is equal to pd.read_csv, and inside this I'll have churn.csv, And then let me have a glance at the first 5 records of all of the columns, and these are all of the columns. And for all of these columns, I'd have to make a box plot between this tenure column, which would go on the y-axis, and this churn column, which would go on the x-axis. SNS.boxplot, and onto the x-axis, I'd have to map obviously the tenure column. Onto the y-axis, I am mapping the churn column. Then I'd have to use the data, which is churn, and I'd have to show it out. So I'll have plt.show. So I've actually made a mistake over here. So tenure will go onto the y-axis and churn will go onto the x-axis. Now, if we get this box plot, and we've already seen the inference, it seems that those people who do not churn out, their tenure seems to be longer than those people who actually churn out. And now this time we'll be creating a box plot between the internet service column and the monthly charges column. So we have the monthly charges column onto the y-axis and the internet service column onto the x-axis. And we've got these 3 different categories in this internet service column. So the internet service can either be DSL, fiber optic. So this no means that the people don't have, or the people haven't subscribed to internet service. And it is very clear that those people whose internet service is fiber optic, they would have the maximum monthly charges. Similarly, those people who do not have internet service, their monthly charges is minimum. So when you compare this box to these 2 boxes, it is very evident that people who don't have internet service, their monthly charges are very, very low. I'll copy the same command over here, but on the y-axis, I'll have monthly charges, and on the x-axis, I'll have internet service. And this is the resultant box plot which we'll be getting. Now we'll go ahead and make another box plot between the contract column and the tenure column. Tenure column would go onto the y-axis, contract column would go onto the x-axis, and we can have 3 different types of contracts: month-to-month contract, 1-year contract, and a 2-year contract. And if we look at the tenure of it, so let's actually look at the median values of the tenures. So it seems that if the contract is of month to month, then the median tenure is the lowest. Similarly, if the contract is of 2 years, then the median tenure is the maximum. And we are setting a palette over here. So again, we can have different palettes. So the palette which I'm using is equal to set1. Onto the y-axis, I'll be mapping the tenure column. Onto the x-axis, I'll have the contract column. Let me write in contract column over here. And the data will obviously be the churn data set. And what I'd have to do is I'd have to use a palette, and the palette which I am using is equal to set1. And this is the resultant box plot. Now you see these boundary lines over here. If we want to change the thickness of these boundary lines, we can do that with the help of this line width attribute. So here I am setting the line width to be equal to 3. If you compare this particular box plot with the earlier box plot, it is very clear that the thickness has increased. The same code, I'll actually have tenure and contract over here. Onto the x-axis, I'll be needing contract. And I will use this line width, and I'll set this to be equal to 3. And you would see that the line width has increased substantially. And after this, let's say if I want to change the order of how these boxes are present. So here, initially the boxes were present in the order of month to month, 1 year, 2 year. But instead of this order, let's say if I want 2 year first, followed by month to month, then after that, if I want 1 year, then I can use this attribute called as order, and inside this I'll pass in the list which will comprise of the order in which I would want these boxes to be present. So here I'll remove the line width, and instead of line width, I'll use this attribute called as order, and first I'll have 2 year. After that, I'll have month to month. Then Finally, I'll have the last box, which will be 1 year. And you would see that I have changed the sequence. Now, if you want to add colors on the basis of a column, which we've been doing throughout, that can be done with the help of this hue attribute. And I want the color of all of these boxes to be determined by this payment method column. So here I am mapping this payment method column onto this hue aesthetic. And as you guys see, I have these 4 different payment methods. I have electronic check, mail check, bank transfer, and credit card. So electronic check. So this particular box, or wherever all of these boxes where the color of the box is purple or dark blue, that denotes electronic check. Then we have the box where the color is orange, that would denote mail check. And if the color of the box is green, that would denote bank transfer. And if the color of the box is red, that would denote credit card. So here I'll add this attribute called as hue, and I want the hue to be determined with the help of this payment method column. And you would see that I have 4 of these over here. So I have 4 boxes with respect to these 3 different categories.
So let's understand now what is Plotly. So as I told you, Plotly is a free and open source library, and it is mainly used for the interactive plots. Now you can also use Plotly to visualize the data, and along with that, Plotly supports several plots such as scatter plot, histogram, line chart, pie chart, area chart, and then it permits boundless customization. So that means, let's suppose that if you are using Plotly, so whatever the output you are getting it, you can zoom in, you can zoom out the plot, and along with that you can pan it. So these customization you will not get in other libraries such as Seaborn or Matplotlib. So this is the basic idea about Plotly. So now, after understanding what Plotly is, now let's see its installation. So basically you can install Plotly using pip in Jupyter Notebook. So you have to write just ! pip install Plotly, or the another way you can install it through Anaconda prompt. So the code that you will be using here, conda install -c Anaconda Plotly. So these are 2 ways I will be installing through pip. So I will be using Jupyter Notebook. So I will go and click on this new, and then I will click on Python 3. And here you can see that I am getting as untitled 22. So let me change the name here, and I will write here Plotly. So this is the name of my file. So now I have to install the Plotly. So let me write here Plotly, and I will comment it down with hash. Now after this, so if I want to install Plotly, so I will use here ! and then I will write here pip, and then I will write here install Plotly. Now let me execute this. So on execution, you can see that I am getting my output as requirement already satisfied. So this shows that my Plotly has been installed. So now let's see plotting in line with Jupyter Notebook. So the best thing about Plotly is that you can generate the graph in online as well as offline mode. So if you want to plot the graph offline inside a Jupyter Notebook, then we have to initiate Plotly Notebook as from plotly.offline import init underscore notebook underscore mode. Then we will write init underscore notebook underscore mode, and then we'll write connected is equal to true inside the parenthesis. So this thing we have to write in order to work with Jupyter Notebook. So let me write here, I will write here from plotly.offline import init notebook, and then I will write here mode, and then once again I will write here init underscore notebook underscore mode, and then I will write here connected is equal to true. Now let me execute this. So you can see that this code has been executed. So now we can work on Plotly in Jupyter Notebook. So now let's see Plotly packages. So we are having plotly.tools, we are having plotly.graphObjects, we are having plotly.plotly. So let's start with plotly.tools. So basically this module contains useful functions that will ease and increases the Plotly experience. So the next package that we are having is plotly.graphObject. So basically this module gives us the graph object, and this is used to represent figures. So now coming to the plotly.plotly module, this module holds functions which requires a response from Plotly server. So this is the basic idea. Let's understand in coding so that we can understand these packages in a better way. So let's understand the Plotly packages with coding example. So once again, I will write here from Plotly dot offline, and then I will import here iplot. So basically iplot means interactive plot. So what I will do here now, I will write here iplot, and inside this I will give argument. So let me write here x, and then let me give the values here. I will write here, let's suppose 1 comma 2 comma 3 comma 2 comma 1, and let me give the y values also. So I will give here 5, 10, 5, and let's suppose 0 and 5. Now let me execute this. So on executing, you can see that I am getting the graph like this. So basically in this graph, if you want to zoom in any point, you can do it. Let me show you. So basically you can see that at this point we are having the x-axis value as 2 and y as 10. Now, so here you can see that I am also having the option of pan. So if you are clicking on this pan button, then I can drag it like this. So basically these are the features that you can get into Plotly, but you can't get in Matplotlib, right? And along with that, let's suppose if you want to download this output image, then you just click on this. And now here you can see that I can download this image in PNG, right? So these are the features in Plotly, right? Now, after getting the idea about this iplot, now let's see the graph object package. So let me write here import. I'll write here Plotly dot graph objects, and then I can give the name as geo. So basically geo means graph object. So I don't want to write large name, so that's why I'm writing here geo. Now what I will do here, I will create here a variable and I will give the name as figure1, and then I will write here go dot figure, and inside this I will write data is equal to go dot bar, and inside this let me create a variable y, and I will give the values, let's suppose 5 comma 7 comma 2, and if I want to display it, then I will write here figure 1 dot show. So let me execute this. So on execution you can see that I am getting an error. So module object is not callable because I have to write here capital B. Now if I'm executing it, then you can see that I am getting my bar chart here. So here you can see that y value is 5 comma 7 comma 2. So this is y is equal to 5, this is y is equal to 7, and this is y is equal to 2. So this is basically a bar chart. And now if you want to zoom in, then this button zoom in, you can zoom in, and then for zoom out you can click on this minus button, and if you want to pan this thing, just click on this pan button and just drag it. And if you want to download this plot, then click on this button. So basically this is the basic idea about Plotly. Make sure that you must know the Python and then libraries like NumPy, Pandas, Seaborn, Matplotlib, so that you can understand everything easily while going further. So the next topic that we are having is various types of charts. So basically Plotly is used to make interactive graphs. So as I told you that with the help of Plotly library, we can make interactive graphs. So we can make graph like bar chart, we can make histogram, we can make line chart, box plot, heat maps, 3D scatter plot, as well as 3D surface plot. So we will implement each one of the graph in Jupyter Notebook. So the next topic that we are having is Plotly with cufflinks. So before understanding cufflinks, let's understand what is pandas. So as we know that Panda is a very useful library that is used for the data analysis, right? But the problem is that Pandas plot doesn't provide interactivity in visualization. So here comes the cufflinks. So what happens here? Cufflink is a library which is used to connect Plotly with Pandas data frame, and it will generate chart and graph from the data frame. So now you have to install the cufflinks because by default it's not available. So you can write exclamation mark pip install cufflinks. You can install it, or either you can go on Anaconda prompt and then you can write there conda install -c conda -forge cufflinks -py. So this is basically a installation of cufflinks. Now after that you will import cufflinks. So I will import here import cufflinks as CF. So here I've written CF because I don't write the big name. And then after that I will write here cf.go and then underscore offline, because I will be implementing cufflink offline. So now after understanding what is cufflinks, let's see it into the Jupyter notebook. So I will be going on Jupyter notebook and then I will click on this new button on Python 3 and then let me change the name of this. So I will write here Plotly library. So after giving the name, I know that first I have to install Plotly. So I will write here exclamation mark pip install Plotly. Let me execute this and you can see that my Plotly has been installed. Now I want to install cufflinks also. So I will write here exclamation mark pip install cufflinks. So you can see that my cufflinks has been also installed. Now I'm assuming that you know about NumPy library, Pandas library, Seaborn library. So if you understand about these libraries, then it will be easy. So now let me import NumPy, Pandas, Matplotlib as well as Seaborn library here. So I will write here import NumPy as NP. Then I will write here import Pandas as PD. Then I will write here import Seaborn as SNS. Now we know that NumPy, Pandas and Seaborn are the Python libraries. So NumPy is basically used for the scientific as well as numerical computing. Now coming to the Pandas, we know that it is used to visualize the data, and then Seaborn, we can plot the graphs using this Seaborn. So let me correct the spelling of this Seaborn. Now after importing Seaborn, let me import the Matplotlib also. So I will write here import matplotlib dot pyplot as plt, and then I will write here percentage matplotlib inline, right? And now let me execute this. So these libraries has been executed. So after this, what I will do, I will write here from plotly dot offline, I will write here import iplot. So we know that iplot means interactive plot, right? And after that I will write here import plotly as py. Let me execute this. So it has been executed. Now if I want to know the which plotly version I am using, so for that what I will do here, I will write here print and then I will write here py dot and then underscore underscore, I will write here version, and then once again I will write here underscore underscore. Now if I'm executing it, so on execution you can see that I am getting 5.3.1 plotly version. So let me import cufflinks. So I will write here import cufflinks as cf and I will execute it, and now I will write here py dot offline dot init underscore notebook underscore mode connected is equal to true. So basically what I'm doing here, I'm using Plotly offline in Jupyter notebook, and then after that I've already imported cufflinks, right? So I will write here cf dot go underscore offline, and then I will write here open and close parenthesis, and let me execute this. So this has been executed. So now here you can see that I have already imported the libraries such as NumPy, Pandas, Seaborn, Matplotlib along with the cufflinks. So now what will happen here? I can directly use the Pandas data frame to display various kinds of plots without using trace and figures of graph object module. So this is the advantage of using cufflinks. Now let's understand how we can use cufflinks. So what I will do here, first I will create a variable. Let's suppose pd1 I am creating here, and then I'm using this pandas as of now. So I will write here pd dot data frame. So I will write pd dot data frame, and basically it's an empty data frame. And if you want to check it out, then I will print here print, and then I will write here pd1. So here you can see that this is the empty data frame. Now what I will do here, I will write here help, and inside that I will write pd1 dot iplot. So as I told you that we can use cufflinks to connect pandas data frame with plotly. So now what will happen here, let me execute this. So you can see that here while executing I am getting here help on method underscore iplot in module cufflinks dot plotly tools, and here you can see that inside this iplot I am getting a kind as scatter, data as none, and here you can have different kinds of charts such as scatter, bar, box, spread, ratio, heat map, surface, histogram, bubble, bubble 3D, scatter 3D. So we'll see all this. So moving ahead, let me write a variable df1 once again, and this time, so let me write here pd dot data frame. and inside this data frame I will be using a numpy. So you can see that here I've already imported a numpy library. So I've written here import numpy as np, right? So here I will write np dot random dot random, and inside this let me write here 100 comma 4, and then once again I will give comma, and then I will write here columns is equal to, and let me write here a comma, and then I will write here b c and then d. So here you can see that here 100 is the row and 4 is my column, right? So that's why I've given the column name as a b c d. Now if I want to print this data frame, so let me write here print df1, and here you can see that on execution I'm getting my output. So as I told you that I am having 100 rows and 4 columns, right? So I'm getting a b c d. Now instead of that I will use here df1 dot head. So when I'm using df1 dot head function here, so basically head function give me first 5 records. So let me execute this. So on execution you can see that I am getting first 5 records from 0 to 4, right? So let's suppose that if I want first 10 records, then I will put here 10 inside this head. So you can see that I'm getting first 10 records from 0 to 9, right? So this is the basic idea. So after this, let's suppose I want to plot this data frame. So how can I do? So what I will do here, I will just write here df1 dot iplot, and on execution you can see that I am getting graph, right? So here you can see that at 0 these are the values, right, of a b c d. At 1 these are the values. So here you can see that we have plot this graph. Now if I am clicking on this iplot function, and if I am pressing the button shift and double tap, then here you can see that I am getting a kind as a scatter, right? So by default I am having a scatter kind, right? So if I am pressing here double tap, then you can see that the data is none, layout is none. So you will get all the information, right? So you have to just press shift and double tap. Now moving ahead, as I already told you about the features of Plotly, so you can zoom in, you can zoom out also this thing. Then if you want to suppose visualize at this particular point, then you can just click like this and you can see, right? Now if you want to pan it, then you can click on this pan button, and then you can pan it, this graph also. So basically this is a graph that you can see that we have made using Plotly. So now instead of Plotly, I will use now Matplotlib. So here you can see that here I've imported matplotlib.pyplot as plt. So now what I will do now, I will just write here simple plt dot plot, and inside that I will write df1. This is my variable which contains here data frame, right? So now if I'm executing it, then you can see that even I am getting the graph here, but the features that are present in Plotly, like you can zoom in and then zoom out, then you can also do the pan, right? But here in Matplotlib, here you can see that we are unable to visualize the data properly as compared to Plotly. So the Plotly provides extra features that we are unable to find in Matplotlib. So now after this, now let's see some more interactive graphs. So now what I will do here, once again I will write here df1 dot, and then I will write here iplot, and inside this I will write here x is equal to, let's suppose I'm assigning c here, and then I will write here y, and I will assign here d. Let me execute this. So you can see that this is the type of graph that we are getting. So using this Plotly, we can have different types of interactive graphs. Now after this, so let's see some more graphs. So I will write here df1 dot, and then I will write here iplot, and let me write here once again x is equal to c, and then I will write here y is equal to, let's suppose d. Now what I will do here, I will set here mode. So I will set here mode as markers, and now if I'm executing it, then on execution you can see that I am getting a graph like this, right? So in this graph, let's suppose if I want to increase the size, so what can I do? I will simply write here df1 dot iplot, and then I will write here x is equal to here c, and then y is equal to d, and then I will write here mode is equal to markers. So I will write here markers, and then I will write size. So let's say I want to assign size as 50, so I will just write here 50, and on execution you can see that size has been increased, right? Let me change the size to 30 so that it can look better. So now if I'm executing, then you can see it, right? So now let's see some more graphs. So what I will do now, I will write here df1 dot iplot. So here you can see that inside this iplot, let me just click shift and double tap. You can see that by default my kind was scatter, right? So I was getting a scatter graph earlier. Now I have showed you that we are having different kinds of charts. So here you can see that if you go here, then you can see that we are having bar chart, we are having box, we are having spread, we are having heat map. Okay, so let me change the kind here. So I will just write here kind is equal to, and then I will write here bar. So if I'm executing it, so this is the bar chart, right? So let's see some other kind of chart in Plotly. So once again I will write here df1 dot iplot, and inside this once again I click shift and double tap. So you can see that what are the kind of charts are available here. We can have here box, we can have spread, ratio, heat map, surface, even histogram. So let's write here histogram, right? So if I'm writing here histogram kind is equal to histogram, and if I'm executing it, you can see that I'm getting a histogram, right? Now once again if I'm writing here df1 dot iplot, and then I'm writing here kind, and inside this I will write box. So let me execute this. So you can see that I'm getting a box chart, right? So this is basically a maximum value of A, right? This is the minimum value of A. Similarly, this is the maximum value of B. This is the minimum value of B. Similarly for C and D, right? So this is the box chart. So you can see that we can make several types of interactive graphs using Plotly. Now, after plotting box graph, let's see this was my bar graph, right? Let's suppose if I want a gap in between. So what I will do here, let me create a new shell. So I will write here df1 dot iplot, and then I'll write here kind is equal to bar, and I will give here comma, and then I will write here bar gap, and let's suppose I am giving a bar gap as 0.75, and if I'm executing it, then you can see that I'm getting a gap, right? Let me zoom it. So you can just click this particular portion to visualize, right? So this is the best thing and the best feature about the Plotly, right? We can visualize the data very easily here. So if I want to see my previous image, so let me zoom out. So this is my bar graph which is having bar gap. Now, so after this, let me see what we are having more in iplot. So once again I will just click inside this iplot function, and then I will just click on shift and double tap, and here you can see that we are having a lot of things here. So if you see here, we are having a bar mode, right? And we can have the bar mode as group, stack, and overlay, right? So let me show you. So let me create a cell after this. So if I'm creating a cell, and if I'm writing here df1 dot iplot, and then I will write here kind is equal to, let's suppose, bar, right? And then after that, so I will write here bar mode as, let's suppose, stack, and then I will write here bar gap as previous one 0.75. So if I'm executing it, you can see that, right? So as the name itself suggests, stack, right? So here you can see that A, B, C, D are here overlapping, right? Now let me create one more cell after this, and once again I will write here df1 dot iplot, and inside this I will write here kind is equal to bar, and then I will write here bar mode as, let's suppose, overlay. And then after writing overlay, what I will do, I will just write here bar gap 0.75, same as previous one. Now if I'm executing it, then you can see that I'm getting the graph like this, right? So after this we are having one more bar mode. So let me copy and paste this thing, Control C, and once again I will copy and paste. So now here, instead of overlay, I will write here group. So let me write here group, and now if I'm executing it, then you can see that I'm getting a graph like this, right? So you can see that we can make a lot of interactive graphs using Plotly. Let's see some more. So after this, let me use couplings. So I will write here cf dot get themes, and if I'm executing it, then you can see that these are the themes that coupling is providing. Now what I will do here, let me implement this. How can I implement this? So I will write here cf dot set underscore config underscore file, and let me set the theme here. So I will write here theme. Let's suppose I'm writing here solar. Now how can I implement it? Let me take the example here itself. Let's take example of this. So let me copy and paste this, Control C, and I will just paste here. And if I'm executing it, you can see that I'm getting a background as solar. Now instead of solar, let's suppose that I want to change it. So let me copy and paste. If I'm writing here, let's suppose polar, on execution, you can see that this is the color that I'm getting. Let me change with some another. So let me copy and paste, and this time I will just use ggplot, Control C, and then Control V. On execution, you can see that I'm getting my graph like this, right? So you can use several themes like ggplot, Perl, solar, space, white, and polar. So now after this, let's suppose if you want to draw the 3D plot, then how can you do? So let me write here once again. I will write here df1, but before that, let me change it to the white. I'm just changing it to the white, or else it's fine also, but white looks cool. So I will just write here white, and here you can see that I am getting in my normal color. Now for 3D plotting, I will just simply write here df1 dot, and the same thing iplot, and I will write here kind, and inside this kind, earlier I was writing bar, scatter, histogram. Now I will write here simply surface, and now if I'm running it, then you can see that, right? This is a 3D plotting, and the best thing that I can drag it, right? So basically you can see that Plotly is used to give us interactive graphs. And then let me pan it. I can pan it also. Let me rotate it. So here you can see that we are getting really cool graphs, right? So I just click on this reset camera to default. So it's my default now. And if I want to zoom in and zoom out, I can do it. So let's see some more interactive graphs. So I will write once again here df1 dot iplot, and instead of surface, let me change the kind. So here instead of surface, I will use here spread. So let me write here spread, and if I'm executing it, then you can see that I'm getting a graph like this. So you can draw beautiful graphs using this Plotly library. So after seeing this many graphs, now let's see about the couplings module. So we are having a coupling.datagen module. So what is it? Let's look into this. So I will write here help, and here we have imported couplings as cf, right? So I will write here cf dot datagen, and if I'm executing it, then you can see that help on module couplings dot datagen in couplings, right? Here you can see that we are having n is equal to 3. So here n is int, and it's a number of points for each trace. Next we are having categories, so it must be also in integer, and it's basically a number of categories for each point, right? Next we are having a prefix, which will be a string, and then columns. So in columns we are having a list of column names, and then again we are having the mode as a string, right? You can use this module for bars, you can use this module for box, bubble, bubble 3D, and even for heat map, and then scatter 3D you can use for histogram also, lines, right? And many more. And you can also use this module for sine wave, and then surface, violin. So now after having little bit idea, now let's implement this. So now let's draw a graph using this coupling datagen. So what I will do, let me create a new shell, and which graph shall I create? So let me first start with the sine wave, right? So here you can see that I'm having a sine wave, and here n is the integer, and it ranges for x and y axis from minus n to n. So what I will do here, I will just write here cf dot datagen, and I will write here dot sine wave, and inside that let me write here n is equal to, let's suppose I'm having 17, and then I will write here the size of increment along the axis. Let's suppose I'm having here 0.50, right? And let's draw this sine wave into the 3D plot. So what I will do here, I will just write here dot iplot, and inside that I will just write kind is equal to surface. So if I'm executing it now, you can see that I'm getting a sine wave graph, right? Let me zoom it here, right? So now after seeing sine wave graph, now let's plot some more graphs. So let's see in data gen what we are having. We are having scatter 3D also, right? So let's plot scatter 3D. How to plot scatter 3D? So once again, I will write here cf dot datagen, and after that I will write here dot. You can see that we can plot here scatter 3D. So I will write here scatter 3D and then n categories, right? Number of categories are there and the number of points for each trace. So let me write here scatter 3D, and then I will write here, let's suppose 5 and then comma, let's suppose 50. So after this, what I will do here, if you see here, then we are having prefix is equal to category and then mode is equal to none, right? So instead of mode, I will write here stock. So I'll write here stock, and then I will write here dot I plot, and let's draw this graph into a scatter 3D. So I will write here kind is equal to, and then I will write here scatter 3D. Then I will assign here x equal to x, and then y is equal to y, and then z is equal to z. So if I'm executing it now, so if you can see that I'm getting here, it's showing unknown mode stock because it will be stocks. So now if I'm executing it, you can see that I'm getting a scatter 3D graph, right? It's a very interactive graph. You can see it in all directions. So now after plotting scatter 3D, so now I will plot a graph of bubble 3D. So once again, I will write here cf dot datagen dot bubble 3D, and then let me write here 5 comma 7, and then mode once again I will give stocks, and then I will write here dot I plot, and after that I will give here the kind as bubble 3D. So I will write here bubble 3D, and then I will write once again x is equal to x, and then y is equal to y, and then z is equal to z, and then I will write here size is equal to size. And on execution, you can see that I am getting a bubble 3D graph, right? So here you can see that we have drawn the graph of bubble 3D using couplings.datagen module. So this is the basic idea about Plotly library.
So first and foremost, let us start by understanding what is business intelligence. So when we talk about business intelligence, in simple words, business intelligence is nothing but the process of taking in raw data and basically putting it or passing it on to a system or a process that would convert it into more meaningful business insights, right? Something that can help you take better business decisions, something that can help you better your business in general. So it sounds very simple, right? I mean, you take in raw data, put it into some machine, and then you get a furnished product, or basically you get business insights. But it's not that easy. When you talk about business intelligence, there are a lot of things that happen in business intelligence, and to name a few, basically what happens in business intelligence is when you take in this raw data, it comes in from different sources and different formats. So into business intelligence processes, basically this data is broken down into more understandable sources so that it can be integrated with existing software and do whatever process you want to do with that data later. So the first step is to basically ensure that the data is in more integratable format. So it gets converted into that first, right? So that you can load it. So when you talk about ETL, that is extract, transform, and load. So ETL or the extract process is where we basically go ahead and extract this data from different sources and make it more or convert it into more loadable format. Then the next step is to load it to a particular database, to a particular data source. And once that happens, post that you transform it into more editable data, right? So when you talk about a tool which is going to take in this data and give you maybe some insights, or basically you are going to run a machine learning model on top of it. In that case, you need this data to be more smoothened, more cleaned, and this process happens in the transformation process as well. So basically when you talk about business intelligence, basically you're going ahead and implementing these set of actions these set of processes to start with, right? So once you are done with it, then you actually go ahead and generate business insights out of it. So that is what business intelligence is in a nutshell, right? So this is something that I talked about from a more technical perspective of what happens with the data. But to give you more laymanish definition or more generic definition, business intelligence, as the name suggests, is used to make your business smarter or to make your business intelligent. Now, as we all know, the amount of data that we have these days is huge, right? So the importance of data, digital data in particular, has increased a lot. Now, what that means is, in order for you to actually go ahead and be competitive in the current market, it is important you understand this data, understand other data as well, as in how are your competitors doing, right? What are the products that you plan to launch, and what is the kind of response that you can expect, right? So there are quite a few questions you can ask to the data. And when we talk about this data, it is nothing but the user data, the census data that we have with us, that is very relevant to the current market. And if we can actually go ahead and understand this data, right, we can take good decisions. Now, you might argue saying the fact that isn't this what data science does for us? But when you talk about data science, it is more towards the technical side of things, where you basically take in data, you process your data, and you basically try to find out an answer to a particular problem. But when you talk about business intelligence, your first step is to ensure that the data is basically ready for you to go ahead and do this data science and stuff, right? So the cleaning up part also comes under business intelligence to a very great extent. And to be very laymanish, basically what we do is we merge both these streams, the process of cleaning your data and the process of understanding your business better using the data, and the whole process together is known as business intelligence. Now you might ask me, is data science a subset of business intelligence? No, that's the other way around. When I say we merge them, we basically take in some features from here, some features from there, right? But when you talk about data science, it again gives you quite a lot of other options as well. And in fact, business intelligence can be easily thought of as a sub part of data science to some extent. But let's not mix these two terminologies together, right? They have different domains, they have different areas of functionality. By now, I hope that business intelligence is clear to you people. If you're still confused, in simple words, basically you take in data that can be in any form, can be raw, and basically clean it in such a manner so that it can help you understand your business better. Okay, so that is what business intelligence is in a nutshell. Let us move further and try and talk about the features that business intelligence has to offer to us. Now, talking about the features of business intelligence, right? So business intelligence is something that helps you in better decision making, right? Better business understanding, quick navigation, and gives you instant answers. Now, all these are relevant to each other and they're connected points, right? When you talk about getting in some raw data, right? It might not be the best of data to go through and to understand. Data is a wrong word, please forgive me for that. It won't be the best of data, right? So to actually go ahead and just start understanding that data, right? It can be in any form, it can be in any size. Let's assume that you have huge amount of data with you. It would be practically impossible for you to just go ahead and take a look at that data and understand it, right? So this is where business intelligence comes into picture. What it does is it first helps you process your data in such a manner that you will be having relevant data with you, relevant and limited amount of information that you need to focus on. Once you get that data, right, it becomes easier for you to understand your underlying business problems, right? Once you understand your underlying business problems, then you would be able to have answers to some of the questions that you're looking for. You'll get some instant answers based on which you can basically go ahead and take better decisions for your business. And thus it supports all the features that we've just discussed here or that are there on the screen, right? So I hope you've understood what business intelligence is and what are the features it offers. Today, we won't be getting into the details of business intelligence because this course primarily focuses on Tableau. So we would be soon diverging towards data visualization. But by now, I hope you've understood what business intelligence is, what are its features. So when we talk about Tableau is an end-to-end tool, right? Right from connection to collaboration, Tableau easily is the most powerful, secure, and flexible end-to-end analytics platform for your data is what the definition says. And that is very true. Now, why do we call it as an end-to-end platform, right? So guys, when you talk about Tableau, it is not something that gives you temporary solutions or short-scaled solutions. When you talk about something like Tableau, it can serve your purposes, be it an individual user or an individual learner, or it can solve problems for enterprises as well. Now, when you talk about Tableau in particular, it gives you visualizations, or it gives you support, rather, not visualizations, pardon me for that. It gives you a support when you talk about setting up your infrastructure. Now, something like an enterprise comes in and they say that I want to use Tableau. Now, for them, just going ahead and using the tool is not the solution. As an individual, you might say that, okay, I'll install this tool, I'll use it. If it does not work for me, I'll use something like that. But when you're talking about an organization, an enterprise, we are talking about a lot of data, a lot of money being invested, a lot of systems, a lot of analysts working on the data. Now, what happens in that situation is, since we have so much data that we are talking about, so much integrations we are talking about, we are also talking about a lot of software compliance coming into picture. So with Tableau, if you have to get in Tableau, you have to consider quite a few things like, would the software integrate with my existing infrastructure? Would I be able to train my resources to go ahead and use this infrastructure? Would it fall into the budget requirements and basically integrate with everything that is there with me, right? So when you have such questions, Tableau helps answer those questions. Basically, when you talk about setting it up in your organization, in your enterprise, Tableau offers support where the team basically comes in and helps you set up a server if required for your data, right? Apart from that, they also ensure that all the installations and all the training of your employees happen as per plan, right? So that whenever you want to use Tableau, an end-to-end solution is given to you. Now, this is an end-to-end solution from a consumer perspective, right? When you talk about an end-to-end analytics tool, right? From data transformation to basically going ahead and carrying out certain statistical analysis on your data, your Tableau takes care of everything that is required. And that is why Tableau is such a popular and an important tool. So by now, I hope that you've understood what Tableau is. If you talk about its features, you have apt visualizations. That means it gives you smooth and nice visualizations. The next point that you see here is automatic function, and both of these go hand in hand, your apt visualizations and automatic functions. Let me explain how this happens, right? So when you talk about apt visualizations, basically what is happening here is with Tableau, there are quite a few automatic functions, drag and drop functions where you put forth your data, and Tableau is smart enough to understand that this is the piece of data that we have with us. Let's just go ahead and create this particular visualization for this individual. So if you put in like two different parameters that you want to compare, it would start by giving you a bar graph, right? Or give you a line graph, which basically falls under an X and Y axis, right? So since we are talking about two parameters, it gives you that direct comparison. So when you talk about something like Tableau and even other tools like PowerBi as well, basically you get these features here where you can visualize your data with a lot of ease, and you have multiple automatic functions that basically understand that this is the data and this is what you need to do with it. It lets you get into the depth of the information, right? So when you talk about creating reports, creating visualizations, it might be easy for you to go ahead and create visualizations using something like Tableau. But as basically when you talk about presenting this data to your stakeholders, they might need detailed information. Every graph might not convey that information that they're looking for. So you might need to drill deeper into some of the concepts, some of the information, some of the data that you have with you. And with Tableau, you can do that with ease. How do we do that? This is something that we'll see in the demonstration part in the later half of the course. It also lets you connect to data. with ease. Now, when you talk about a tool like Tableau, it connects to so many data sources, and it does that so readily and so easily that basically it becomes easier for you as an individual to just go ahead and choose a particular data source and get that data from that particular data source. There would be quite a few databases that can actually not connect to Tableau. In fact, I don't see any database that is out there that cannot connect to Tableau, at least the ones that I've used. I'm sure there would be some, but even if they're very less in number. So that is what Tableau is in a nutshell. I hope you've understood the basics of Tableau. Let's now go ahead and discuss some of the other components that Tableau has to offer to us. Let's try and understand how the Tableau architecture looks like, how the architecture of Tableau works. If you talk about Tableau architecture, there is not a lot of thought process to put into it, right? Firstly, we would be connecting to different data sources, as I've mentioned. So you are talking about taking in data, extracting data from different sources. Once that is there, you can move that data to a Tableau server. If you are talking about an enterprise level application, yes, you would move it to a Tableau server. And that is where, if required, if you have another database where you have security concerns, you can move your data using a gateway to that particular data center, right, where your data remains safe. So again, if you need to process that data through the gateway, you can again move it to your Tableau server or to your desktop, where you can actually go ahead and create reports or visualizations out of this data. So when you talk about architecture of Tableau, it follows the three important steps that are very crucial for business intelligence. Those steps are your data integration, your data processing, and data presentation. That means, again, basically you're taking in your data, right, from different sources, integrating it so that it basically amalgamates with your existing support tools, right? Then you process it. If required, you'd clean it. You would basically transform this data and then use it for visualization to present the meaningful information that you're trying to present out of this data. So that is what Tableau architecture is in a nutshell. Let us now go ahead and discuss some of the other pointers. Let's try and understand Tableau product family. Okay, so when we talk about Tableau product family, there are quite a few things that we have on our plate. You'd be getting some developer tools that are there. Apart from that, these are the standard products that Tableau offers. You have your Tableau Reader, you have your Tableau Public, you have your Tableau Server, you have Tableau Online as well. Let's try and understand them one by one. I'll first start with Tableau Public. I'll come to the Tableau Reader part, the latest or the last. So let's just go ahead and discuss Tableau Public first. So when you talk about Tableau Public, so basically when you talk about it, it is mostly used for users that want to optimize their costs, right? And that is why it's public, because it's available publicly, right? So whatever workbooks that are created, you do not save them locally, right? But they are saved on your public cloud, which are basically accessible to other stakeholders that you feel are important to you, right? When you talk about it from a privacy perspective, there's very less to no privacy here for the files that are saved on cloud, since anybody can download this data from here, right? So you might wonder, as in, why do we use something like this? So Tableau Public to some extent again also supports learners, also supports people where you want to share information, and in terms of cost optimization too, it is fairly good, right? So if you do not have any mission critical data, you can definitely put that here on Tableau Public. Then you have something called as your Tableau Server. So Tableau Server again is fairly important. So Tableau Server is specifically used to share your workbooks, your visualization data, information that you create using your Tableau desktop. Okay, basically using the application that you have, something that we are going to use in this demo. Okay, and you can share that across the organization. Okay, so if you have an organization wide goal and you want to keep your data more private than what it would be in your public Tableau Public server, right? So you can use your Tableau Server, which is very organization specific, right? And once you've uploaded your work to a particular server, what it will do is it will be accessible only to the licensed users that you have. So your security is maximum here, right? When you talk about being accessed by the licensed users only, right? So they need not have Tableau server installed, right? They can still access some of the data that is there. Okay, all they have to do is they need to have right login credentials, and they can actually go ahead and check these reports using a web browser as well. When you talk about security, again, as I've mentioned, it is fairly high here. And when you talk about sharing your data effectively in the organization, even that is supported here, right? When you talk about who gets to control all the information here, you'd be needing an administrator for the organization or for this particular server, would have full control to all the resources that are there on the server, be it your hardware, be it your software. It has to be maintained by the organization, and the admin has to have access for all these things. Now, we've talked about what Tableau Public is. We've talked about what Tableau Server is, right? Let's talk about Tableau Online. Now, right from the name itself, you can make out that it is a tool that is online, right? So when you talk about Tableau Online, it's a sharing tool offered by Tableau that lets you share your data online. It functions very similar to what a Tableau server does. But when you talk about the data, again, the data is hosted on the cloud and it is maintained by the Tableau groups. So it's not as generic as public, but it is generic in nature. It is less secure compared to your Tableau server, but more secure compared to your Tableau public. Okay. Here there is no storage limit for the data that you can put on the online part or the online tool, right? What it does is it creates a direct link, which is for like 40 plus different sources, right? Which can be hosted on your cloud, right? Or which can move your data to your cloud. It can be your SQL databases. It can be your Hive data sources, something like Amazon Aurora. Aurora is one of the database services that AWS offers, right? Which is a cloud platform. Spark, SQL, right? All these things, Spark SQL rather, together when you talk about it, it again is a small offering that Spark has to offer to us. So you can use Tableau Online to do that. When you talk about Tableau, basically online in particular, you can go ahead and publish your workbooks to Tableau Online as well, right? From your desktop, like we did in the server part or the Tableau server part, right? So this is how Tableau Online works. And then you have something called as Tableau Reader, which again is a Tableau tool that basically lets you read the files that are there. So when you talk about Tableau Reader, it is a reader tool. So you need to have it installed on the user system or on the user device. Even Tableau mobile products are there that support Tableau Reader features, where you can read or take a look at the visualizations that are there. You can interact with the visualizations that are there. But understand an important point. You cannot create or change the existing dashboards or reports that have been shared with you, or dashboards rather, right? So what that means is somebody who has created a dashboard or a report will have to share that with you, and you can access that using Tableau Reader, but cannot actually go ahead and edit or work on those resources. So that is what a Tableau product family looks like. As I mentioned, there are other things. You have Tableau developer tools, right? Which basically let you create dashboards or your desktop devices, right? You have certain sharing tools as well, which let you share your data, right? So some of them we've discussed here. And when you talk about the desktop version of things, it also has subtypes, right? You have your Tableau desktop personal, you have your Tableau desktop professional, which have different features. So this is what Tableau product family looks like. Let's move ahead and discuss how to go ahead and install Tableau. So the Tableau installation part is fairly simple. You do not have to go ahead and put in a lot of thought process into it, right? Let me quickly show you where you can get the installation details, and I'm sure you can go ahead and do that. So for you to install Tableau, all you have to do is type Tableau, right? And I'm sure you'll get all the information. You see Tableau products, Tableau desktop. Okay, let's look for Tableau installation first. Yeah, install Tableau desktop, right? And to do that, you'll have to come here, right, and get all the information here. So basically what they'll ask you to do is sign up for you to download Tableau, and there's a reason for it. Tableau desktop, yes, there you go. So there should be an installation link somewhere. These are the steps by which you can install Tableau, right? Or I might have missed where we can get. Okay, we don't have a Tableau in download guide here. So this is an installation guide. You can take a look at it. Just type Tableau download rather, and they should help you download Tableau desktop. You see, you enter your email ID here and the file would be given to you. Okay, let me see if I have any demo ID with me where I can go ahead and put it. There you go. You can see it's a 500 MB file, right? You can go ahead and download that. I'm not gonna do that. I have it installed. So I'm gonna just go ahead and cancel the download process, right? Why do you want to download and install it again? So come here, download this file and go back to the previous page, and you'll have a detailed information as to how to go ahead and install Tableau on your system, you see. And it's a very easy process, a few clicks. So you'll have Tableau installed on your system and you won't have to put in a lot of effort. You see, step-by-step information is given. All you have to do is come here and download it. Once you do that, it's like a 2-3 step process. Install, next, and you're done. And you should be having Tableau up and running. And this is how the interface of Tableau would look like for you. Okay, continue. Sign in. You'll be needing an email ID, guys, when you sign in. The reason for that is when you install something like Tableau, it is a licensed tool. Even though it is freely available, it is freely available for a limited duration. So you can sign up for a learner account and you can download it, and it supports majority of the features when it comes to visualization. So once you have that free account with you, you can go ahead and do a visualization using it. So that is why having an account, an email ID to sign into this tool would be beneficial for you. So make sure you go ahead and download this particular tool, and once you do that, you would be more than good to go ahead and get started. So this is what Tableau installation is all about. I'm sure that we don't need to spend a lot of time doing it. So let us now go ahead and understand Tableau data types. Now when you talk about data types are nothing but the type of a variable. Now when you talk about variables, these are nothing but containers that hold data, right? If you know what programming jargons are, you'd know what data types are. But in simple words, these are nothing but the type associated with a variable that holds data, right? Let's assume that you have a particular type of data. Let's assume that you have a number that you want to store. So you would store it in a variable like a, right? And you would store that number as 123, right? So 123 is nothing but an example of a numeric data or a number kind of a data type. Okay, so this is what a data type is. It is nothing but a type associated with a particular data or a particular variable that holds data. So when you talk about Tableau, all the data in Tableau basically will have one or the other type of data type associated with it, right? So if the data is in the form of numbers, right, as I've mentioned, something like 482 or maybe 1.1 or 1.32, right, etc. So these are nothing but your numeric data types, right? Your data can be text or string in nature, right? So it can be something like, hey, hello, welcome to the course, right? Which is nothing but a string, collection of words, or it can be a single word like hello. So which is again textual data, and the data type here is text in nature or string in nature. Okay. Then you have your geographic data. So when you talk about geographic data, it can be something like your state in USA, like Chicago, or a state in Maharashtra, or in India, like Maharashtra, or like Karnataka, right? Which also has cities like Bengaluru. In Maharashtra, you have Pune, Mumbai. Now, these are geographic locations. And when you put forth this kind of data, it is called as geographic data in nature. Any geospatial data basically falls under your geographic data, right? Now, it can be your date and time or date kind of a thing. Say, for example, 18th August, 1892, right? This again is nothing but a date. Now, if you say 18th August, 1892, 5 p.m. Now, this is your date and type kind of a, date and time kind of a data type, right? And then you have your Boolean, which is nothing but your true and false kind of data type, right? So when you talk about true and false kind of data type, it falls under Boolean data type. Again, when you talk about Tableau, your numeric data is basically has hash attached to the data type, or basically it is preceded by a hash. Similarly, for text and string, you have ABC with A capital, right? For geographic, you have that globe sign. And when you talk about date and time, it has watch and a calendar. When you talk about your date, it just has the calendar. For Boolean, you have T/F written. So this is how the data types, or this is how the data types in Tableau are represented. As we get into the demo part, for this course, I would basically go ahead and show you these data types that are associated with the data set or the sample data set that we are going to use in the demo part. But by now, I hope the different data types that Tableau has to offer to you are clear to you people. Okay, so till time we've seen how to actually go ahead and install Tableau, and we've also talked about Tableau data types. Now what I'm going to do is I'm going to quickly go ahead and show you how to go ahead and work around with Tableau interface, how to connect it with data sources, or how to import data into Tableau. Okay, so let's do that. Let's get familiar with Tableau interface. So as we know, this is how the Tableau interface looks like. Now you know that it is a desktop version. As I've already mentioned, when you talk about a desktop version of Tableau, it is meant for audiences that basically want to learn Tableau. So this is a learner's version. So it has an expiry of 14 days when you install it. So this got installed yesterday for the demo sake. So this has an expiry of 14 days. Once you exceed that, I think it still continues to work. I've had an experience using this, but that is what the standard expiry is. After that, probably you'll have to either renew it, or maybe if you're lucky enough, you would be able to continue using it. So this is how the interface of Tableau looks like, okay, to start with. And you can actually go ahead and import data from different sources. What I'm going to also do is I'm going to show you another data visualization tool which is highly popular, and we've talked about it. So I'm going to talk about Power BI tool as well. I'm not going to get into the details of Power BI since this being a Tableau course. Let's not talk about that to a greater extent, but just that you people know how Power BI looks like. I'm just going to open it and show it to you as well, so that we can compare it head to head, as in how do the interfaces for Tableau and Power BI look like. However, I see that there's been an update for Power BI as well. This is not how the icon looks like when you actually go ahead and use or open Power BI. So not worry, there are some minor changes. You see, we never had this, as in if you wanted to import data, you would always come here and import it. This is something which is a new feature. So that's a good add-on, but let's try and compare these two interfaces so that you'd get a clearer picture as to how Tableau works and how Power BI also works. There's not a lot of difference, but let's do that. So if you talk about the ways to connect Tableau to a data source, there are plenty of them. Once you connect to it, we'll get to see the interface. Unlike Power BI, in Power BI, you have the interface that is already opened where you can start visualizing your stuff, right? But when it comes to Tableau, first thing that you do is you actually go ahead and import the data, and only then you move to the interface where you can actually go ahead and create visualizations. So you can see when you talk about connecting to different data sources, Tableau gives you plenty of options, right? So when you talk about these options, you can connect to Tableau server, right? You can connect to files like Excel, text, JSON, Microsoft Access, PDF files, spatial files, statistical files, and more. So the options are more. I mean, to be very frank, I've mostly used text CSVs or maybe Excel files. So that is what people mostly use, right? But again, if you're connecting to a server, you never know, you could be having different files as well. So you have the option of choosing those. When it comes to servers, you can connect to Microsoft SQL Server, right? MySQL, right? You can connect to Oracle, Amazon Redshift, which is an Amazon database service, which probably helps you spawn database instances. That is the service. So you can connect to that database service as well, so that you can take in data if it is there. Or you can just scroll down, and if you are somebody who's new, you can just go ahead and open one of these data sets and start working on them. So if you connect, or if you select or if you just click on Microsoft Excel, it would open a tab for you where you can actually go ahead and import a particular Excel sheet. As simple as that. For this demo, I'm going to go ahead and use a sample data store. So I'm going to keep it open. So when you do that, when you import the data set, you can see right away the data has been imported. Now again, there would be an option of loading and transforming, but since this is an inbuilt data set, it is already clean. You don't have to work around it. So you have all the details in here, right? So you can see that on the left hand pane, you have all the details about what is what, right? What are the different segments that you have, right? So you have all these attributes, all these columns with you, right? And there are certain measures as well. We'll discuss what measures are and stuff, but that's for later part. But this is how the importing of data looks like, right? Post this is done, you can go ahead and again, if you want, you can connect to different sources here, right? If you want to connect to a new data source, you can do that. Even that is an option for you, okay? And on these right hand side, or on the right hand side, you have the option of creating visualizations, right? So these are the by default visualizations that Tableau offers to you. So once you select one of these, right, and open it, you have the option of choosing visualizations for it. You can see you can choose the visualization for it. So you can do that here. But we'll talk about that in detail in the visual analytics part, or the visual analytics demo part, where we'll discuss these at stretch and in detail. Okay. For now, let's just take a look at the interface. Here you can see, if you hover down here, you'll see that there's an option of creating a new worksheet. Worksheet is nothing but a sheet where you can create or put forth your visuals or visualizations, right? And then you have an option of going ahead and creating a dashboard where you can go ahead and put forth your different visuals from different sheets. We'll talk about dashboards as we move further. Do not worry about that. And there's an option to create a story as well. So in the later half of the course, where we are talking about demo or we are getting into the details of Tableau, this is where we'll explore these two concepts. But for now, that you do not have knowledge about dashboards, probably these won't make a lot of sense for you. So this is how the interface looks like. This is where you put in the marks, as in what kind of visualization you want. Do you want to add any color and stuff for it? You can choose all these things here, right? And when you talk about the show me option, you can minimize this, right? So if there are other informations, other details that you have when you start visualizing, those would be displayed here. You can scroll down here if you want to, right? And again, then there are other options here that are very pane specific or very visual specific in nature. So we'll come to details on those topics, but what we'll do first is we'll probably go ahead and discuss some of the important concepts, and post that we'll go ahead and get into the details of the demo. One last thing that we need to discuss here is, I talked about different data types that we have in the previous bit or in the previous video. If you talk about those data types, you can figure out those data types here, right? You can see that there's ABC written here, indicating that this is your textual or basically your string kind of data, right? This is order date. I mentioned your date always comes in with a calendar. If there was time mentioned in the data set, this would have had a clock here, right? And again, ship date is in the calendar form. If you see, these are the geospatial data or the geographic data, and it is represented by globes, right? So again, your data would look different in each case. And if there are numbers, those would be represented by, okay, are we suggesting that there's no number here? That's very difficult to believe. But yeah, there's here, right? You see the hash sign indicates that there are numbers as well, right? And this is basically a function that is being used here. When you say profit, there's a formula that gets in, and since we are binning it, we see a different sign here altogether. Okay, so again, your data, depending upon the data type that you have, would look different to you. And this is how the interface of Tableau looks like. This is how you connect to different data sources, be it Tableau, be it Power BI, and I hope that gives you some idea about it. Let us now move ahead and talk about Tableau dashboards. Now, before I actually go ahead and talk about Tableau dashboards, I would like to first talk about reports and visuals in Tableau, right? So when you talk about Tableau, basically what it does is it classifies its data into different types. First, you have your visualizations or visuals, as we call it, right? So let's assume that you want to represent profit and sales for a few years, right? So you'd be having a particular kind of graph that represents this data. Now these graphs are called as your visuals or visualizations. Now when you basically go ahead and put forth these visuals or visualizations together, we are talking about building a report. Now a report could have multiple visuals in it that concern a particular topic. Let me give you an example here. Okay, so when you talk about, let's say we have some marketing data with us, or we have data for a marketing team. Now in a marketing team, you have like 15 people and you want to create their monthly report. So what are the parameters that you'd be focusing on? Let's assume that there are certain KPIs, right? Or there are certain things that these teams or this team in particular does regularly. Say for example, they basically have 2 hours of basically client interaction, right? 2 hours of basically some brand building or something like that, right? XYZ. Now I'm not going to give you any example about that, but let's assume that. So what about if we are to put forth this data together? Now, when you create a report, you could be having different charts or a particular set of charts that represent all this information at one place, right? So basically this is nothing but a report where you have a particular data source from which you're creating multiple visuals that concern that particular data set, right? So this is what a report would look like. Now, when you talk about dashboards are nothing but think of it as a canvas or a single page, also known as canvas, as I've just mentioned, as you can see on the definition on the screen, right? It is a single page or a canvas where basically you can go ahead and put forth visualizations from different reports. Now you might ask, as in this is nothing but a big report, right? The fact that you can actually go ahead and pick up data from different reports, but try and understand the minute or the granular difference that is here. Okay, when you talk about a dashboard, it is used to convey a longer story or show you a bigger picture, right? Let me give you an example. Okay, let's assume that you have Harry Potter movies. Okay, now when you talk about Harry Potter movies, each of these movies have some peculiar information about them. So if I'm creating visualizations to represent movie information, and I have I have certain set of visualizations that concern every movie. So every movie's data would fall under a report. But let's assume that I want to draw a picture or a storyline that connects all these movies together, right? Some important pieces of information that connects these movies together. In this case, I would be creating a report, right? So what I will do is I will pick up some important pointers or some factors that are either common or different for all these movies and put them on a single page. and connect the dots, right? So if I can do that, this single page or this canvas is called as a dashboard. A report, as I've already mentioned, is a detailed information, can have many visualizations, but that concern that particular data set or a domain. In this case, that particular movie. Let's assume that a report has information about all the things that have happened in part 1 of this Harry Potter series. Similarly, for part 2, we have report 2, and similarly for how many parts? We have 8 parts, right? So for 8 parts, we have like 8 reports. But I do not want all that information. I want something that just helps me build stories and some important pieces of information from every report. So I can pick that up and put it on a dashboard. A dashboard is where you can interact with the data but cannot change it. If you have to change it, you'll have to go back to the visual that was there in the report and then change it. So that is what a dashboard is. Dashboard is nothing but something that you notify people to, right? Now, again, coming back to the office example, let's assume that just like the marketing team, I have n number of other teams in the company. As a owner or as a stakeholder, I do not want all the nitty-gritties that are there in the individual reports of every team, right? Just like we talked about the marketing team. So what we can do is we can pick up some of the features, some key metrics that the stakeholder wants to look into. And in that case, I can create or have those visuals pinned onto a dashboard where I'm building a story for the entire company with information in little amounts for every team that draws a bigger picture. So that is what a dashboard is. As you can see in the definition, it is a single page, also known as a canvas, that uses visualizations to tell a particular story. It is limited to one page and a point note, or a point to note rather, is that a good dashboard contains only the important elements of that story and not everything. As I've mentioned, you might not need, or you will not need, all the information that concerns a particular team or a particular part of the movie, the pointers that we were discussing, right? But instead some key pointers, right? Or to give you a clearer picture, let's assume we'll stick to the Harry Potter example. What are the key things that happened in these movies, right? So if you watched a Harry Potter movie, this example would make a lot more sense to you. Okay, so when you talk about the first part, the Sorcerer's Stone was the main thing there, which Harry Potter got and Voldemort did not, right? So that could be a key part. The second movie, if you talk about it, we got to know that Harry Potter was not the true heir to the Slytherin house, right? Again, an important point. So maybe pointers like these, if you can like bring them together, connect them and build a story, you can pick this important information from every report and put it on a dashboard. That is what a dashboard is for you. I hope by now you've understood what a dashboard is. Okay, so till time, we've already seen what dashboards are and we've been introduced to the interface of Tableau, how it works and all those things, right? So let us now go ahead and get into the demo part. This is where we'll be talking about visual analytics. We'll talk about different visualizations, charts, graphs that you can create using Tableau. So this is where we'll truly get introduced to the interface of Tableau. So let's do that. We've already seen how to install Tableau, right? We've already seen how the interface looks and how the interface for Power BI looks as well. So now that we'll be creating visualizations, you'll get gooder comparison or a better comparison of how do these two things work with each other, okay? Or how are they different from each other? So let's try and do that as well. So before we get into the visualizations part, there are a few basic things that you need to know, right? So when you talk about visualizations, there are different kinds of visualizations that you might have on your plate. What are the most common ones that you can think of? Well, if I were to name them, right, I would be considering bar chart as the first one, right? The next one would be, I hope this is visible to everyone, so I'm just going to go ahead and increase the font size. Bar chart. You have your line charts. You have something like histogram, which is a subtype of bar chart. We'll talk about the differences as well. You have your line charts. As I've mentioned, you have your pie charts. So these are some of the most commonly used charts out there in the market which people use, right? And I assume that you people know what these charts are. So we'll discuss them one by one each. So when you talk about a bar chart to start with, right? Or which is one of the most basic type, right? So bar chart in simple words is nothing but usage or comparison of two variables or presenting two data variables with a common graph, right? So these are more building kind of things that you see in the image. I'm sure that you all must have seen those graphs. We'll see that as we get into the details. But if we were to define it, basically bar graphs are the ones that show numbers that are independent of each other. If you talk about an example that represents bar chart or data that concerns bar charts or bar graphs, right? It would be nothing but assume that you have some data which can include a number of people that either prefer something like food, right? Chinese food, or some who prefer Indian food, right? So these are two categories, right? So if you are to represent this kind of data, right? So you can do that using bar graph. To give you another example, profit and sales, right? You can represent this data by using a bar graph as well. Then you have pie charts. Okay, so when you talk about pie charts, again, in pie charts, basically what we do is, let's assume that you have an entity, you have some information. Let's assume that you have information about population. So you want to find out what is the male and female population. So maybe you can use something like a pie chart. It is nothing but a circular representation of data where basically in that circle you can create parts, subparts, and each part you can think of it as a pie, right? Or pizza in other words, right? Pizza slices. So every slice can represent particular information about that particular data that you're trying to visualize. If I were to visualize population and if I were to find out the male and female population, half the part would be half pie, or half the pizza slice would be representing male population and the other half would be representing female population in whatever percentage they have, right? So that is what a pie chart does well. If you have an entity, you can divide that into smaller entities, smaller graphs, or smaller pie here. Okay, so basically it is used to represent the whole, which is divided into different parts. Then you have line graphs. When you talk about line graphs, they represent information that can change over time, right? Let's assume that you want to find out sales. How are the sales progressing every year? Then by default, a good visualization for it would be a line chart, right? And then you have something like histograms. Even Cartesian's graphs are something that are used widely, but let's not complicate things. Let's talk about histograms. Now, these are type of bar graphs. When you talk about histograms, but they represent continuous data, continuous intervals of data. So as we get into the demo part, which we are already in, we will see all these graphs one by one. So let's try and do that. Let's try and understand these graphs one by one, see how do they work. Now that we know what graphs are and how do they look like, we haven't seen them, how do they look like, but you have some idea about it. So when I talk about these terms, they would start making a lot more sense to you. That is why I felt it was important. We first discussed what these graphs are and how do they look to start with. Okay, so let's just go ahead and talk about Tableau a little before we get into the visualization part. Now, if I hover around here, what you see here is basically you see a blue color on every hover that I make. So this blue color represents dimensions. Dimensions are nothing but your independent variables that are something that convey a particular set of information. When you talk about your other half here, these are your quantitative measures. Okay, so when you talk about quantitative measures, these are dependent variables. Okay, so this is where basically your quantitative measures would come into picture, and what quantitative measures do is they calculate a certain value. So when I say give me profit, the question would be of what? Are you talking about a particular product, a particular category? So if I want to calculate profit for a particular category, I'm dependent on the category variable, right? So when you talk about your measures, they are dependent on your dimensions for giving you certain set of values, certain set of result. So basically when you talk about Your data, when you import it, you basically are dealing with dimensions and measures that would help you create visualizations. Okay, so this is one thing. The other important point that you need to notice, how do you go ahead and create visualizations using Tableau? So let's just go ahead and create a basic one. Okay, the first thing that I'm going to do is I'm going to pick order date. So when I double click on it, you can see that the date has been represented here. So I talked about the fact that Tableau being automatic, it gives you quite a few automatic functions. So when you put forth date, the best thing that Tableau could think of was creating a table here. So when I double clicked on this thing, it created a table for me by default, right? So when there's a table here, what that indicates is this data is best represented, or Tableau feels that it can be best represented by a table. You see, this is recommended is what it says, right? So you can go ahead and create all these kinds of visualizations if you want. You can choose them as well if you feel that they can fit in better. Now let's try and pick up something else. Okay, so guys, the one option is you just double click on it, or you can drag and drop it in the columns and rows depending how do you want the visualization to look like. Okay, what are the other things that you can do here? The other thing that you can do here is, let's just go ahead and let's try and pick up something. What should we pick up? Sales. Let's go for sales since we've been talking about sales. Okay, you see, so it has given me sum of sales here, right? So on yearly basis, it is giving me how much sales have happened per year. Okay, if I come and put it here, you see, by default, what did Tableau do? It realized that we can have a line chart here. I explained the part that when I said we use line charts when we are to compare values in time, right? So best way to do is using line charts. So you see, by default, Tableau knew that we can create line chart for it. I did not select the line chart part. You see, there are values here. So in year 2016, these were the sales that were there. These were the profits. Sorry, these were the sales that happened in 17th, 18th, and 19th. Okay, so if you just go ahead and drop in profit here, you see, you've gotten 2 line charts, right? You can actually go ahead and have it in one set as well if you want, but by default it creates 2 for you. Okay, and let's assume that now I feel that I want some other kind of visualization here. Okay, so what you see here is by default it is automatic here. So when you select the marks, whenever you put forth or click on any of these, it would by default choose what it feels. When I say it, I'm talking about Tableau. What Tableau feels is the best visualization for the data that you've entered. You can go ahead and select this manually as well. You see, I just selected bar, and by default it did go ahead and change it to bar, right? So when you talk about Tableau, it is smart enough to choose these visualizations for you. And when you talk about Power BI, it is no different than Tableau. You can do these things in Power BI as well. We'll discuss that, but little later. So now we know that this is how it works. I'm going to go back to being automatic. There are certain things that I need to discuss since I'm not focusing a lot on these pointers. Okay, so let's just go ahead and remove these. There's something else that I've been wanting to show you. So let's do that. We'll create these visualizations again because we are planning to talk about reports as well. So we'll be needing these visualizations. Do not worry about that. Let's just go ahead and let's select profit and select again order date maybe. So I do not like this visualization at all. I'm gonna remove this again. There you go, this has been removed. Okay, let me just create one more sheet here and do it fresh. I'm going to double click on it and I'm going to look for profits. You see, so it gives me profit for all these things, right? So you get different visualizations if you want. You can choose different marks as well. If you select bars, you see it's giving me bars as well, right? So when you talk about creating visualizations, you have options of choosing how do you want this visualization to look like. You can also come here and select different options if these are valid for the data that you're trying to view. Okay. Now let us just go ahead and play some drag and drop if we can. Okay. So I'm gonna just go ahead and say order date. Okay. And I'm gonna come back and say profits. So it's binned. That is why this data is looking so different. So let's go back to the sales part of things. Okay. So you can see now by default it has picked up a bar graph for this information that we have with us. So you get to choose all these things, and when you scroll down you'd realize that there are more options for you. Again, if I click on circles, you see the data would be represented in circles here, right? So this is limited amount of data that we have when you talk about profit, right? So if I remove this from here and if I put forth something else, let's say we put in the region here, you see all the information here would be represented region wise, you see. And if you come here to analysis, you see it's aggregate major. Do you see the difference here? Let me explain what just happened. Okay, so this data again, I'm gonna shuffle it. I'll show you how to do the shuffling part. It's not very complicated. This icon here lets you shuffle your data. Okay, so you see you basically have all the data here, and what I did was I just clicked on aggregate majors. So when you say aggregate, it is basically averaging these things for you, creating an aggregate of all these values. If I want to see all the data points that are there, I can just come here and say non-aggregated, right? So I'm getting basically these are nothing but sales for Alabama state, right? And these are basically the values for every bit that we have, every unit that we have. So you can create visualizations in this manner, right? There are quite a few other things that you can do with the data as well. Let's assume that we remove the states part from here. Okay, and instead of the states part, even the sales part, let's remove this for now. Let's just go ahead and again pick in the profit part, and with that I'm gonna go ahead and pick up a category stuff. Okay, so I have category wise. Okay, this is still in that zone, and I'm gonna just go ahead and keep it automatic. Okay, I'm gonna come here and I'm gonna say give me profit as per the category. You see you'll get all the profit that is there as per the category that you have. So since this data is getting binned, it's looking very different than what it should be, something that we do not want here, right? So let's just go back and do it again. So there's been too much to and fro in today's demo. I understand that this profit stuff is basically binned value, so that is why we are getting so much problem when we are trying to put forth the information here. You see, so you get the category of profits, right? And you have the information here. Let's assume that I again want it in circles, so I'll get all the information here. And to do that, let me just go ahead and put forth my category in color. You see, you can actually go ahead and differentiate or have different colors for these things. If I just say do not aggregate the majors, you'll get different colors here. You see, this is how it works. If you go for a line, you'll get a line of different colors. So you can go ahead and play around with the data here. Show me is telling you what kind of representations you can have, right? And it will give you information about that as well. Here you can see that there's an option for you. If you click here, you can basically go ahead and highlight a particular selected item which is already done. You can show title, you can even hide certain stuff here if you want. So there are options for you. If you hide the card, the card would be removed from here, right? So you have the option of doing those things, right? Apart from that, all the data that you have, you can actually go ahead and arrange it in different forms as well, ascending, descending order. This is not the best of data to represent that. We'll take a look at other forms of data as well, and you can actually go ahead and change the axis as well. You see? Okay, so I'm gonna go ahead and move to bar graph. The reason I want to do that is I want to show you other things as well. Can you add markers to the data that you have with you? click on this icon. Okay, this for some reason isn't working again. Today the demo part is way out of process, something that shouldn't have had happened, but let go, that's completely fine. We'll talk about markers again. So this is one visualization that you have. Let's go ahead and create one more. We've talked about bar graphs and we see how bar graphs look now. This is how a bar graph would look like for you. Let me just rotate it so it looks different. Let's come here. Let's talk about something else. I'm gonna go ahead and pick up my categories to start with. So where are the categories? If I come here, yeah, there are categories here. So I'm gonna go ahead and put my categories here. Okay, and for the categories, again, let's calculate let's just go ahead and see discount if we have any. Yeah, so this is the discount that you're getting, right? So these are the discounts in percentage you have on these categories. If you go to show and if you select a particular graph, which again is an unfortunate way for me because I'm not able to use all the visualizations that I want to. This dataset isn't the best sub dataset to actually go ahead and play with. So let's just go ahead and look at this to start with. You see, so what you see here is you can see sales based on the category now, and this is how the pie chart would look like for you. You see, this is how you go ahead and create certain set of graphs, certain set of visualizations. Okay, now there are other things that I've been wanting to show you. Those are, I will see or go through certain set of changes that we have. Let's go ahead and pick up the profit, not the profit thing, the sales thing, which has been working for us this long. I'm going to put in my sales and I'm going to put in my order date here. So let's do that. So I'm getting sales as per the order date. Now I want sales for all the categories that I have. Okay, so let's just go ahead and pick up a category field here. And put it here. So you see, I'm getting sales as per different categories that I have with me. Okay, so if you see here, there's an icon here. What happens if I click on it? So guys, if you just realized what just happened, you see there was a subcategory that was added. It's because we have a subcategory here that you can actually go ahead and play along or play with. So this is how you actually go ahead and subcategorize your information. So when you talk about the subcategory and category, if you just scroll down here, you'd notice that there is a hierarchy for these products, right? So because under a category, you'd be having a subcategory. You see, so if you click on this icon here, you see there are options here. There's an option of hierarchy. Do you want to remove it from hierarchy? Let's assume that you remove it. Okay. And now if I remove this, if I click on this icon, I do not get subcategory here. Why? Because we've removed subcategory from the hierarchy. So I remove it. Okay, and I just go back and add it to hierarchy. Okay, so it would be under product. So, and if I just move it, it should be somewhere here. Okay, now let's try and do this. There you go, it's back here. So this is how you aggregate your data using Tableau. You can decide what categories do you want to go ahead and or under what subtypes do you want your hierarchies to be with. Now for year, obviously it is year order date and it is on yearly basis. So if it has any subcategory, if I click on it, it should give me the data accordingly. And now you can see the data is represented in quarterly format, right? So back then our data was mostly classified on yearly basis. Now you see the data is classified on quarterly formats. So if I just go ahead and click on this and put it back, it would be a little more visible. The visualization wasn't the best then. The reason was we had too many subcategories in it. Now what you can see is the data is properly classified, where you have your order date and you have it on quarterly basis. Apart from that, you have the data classified as per the category that you have with you. So this is how basically some of the basic fundamentals of visual analytics work like. There are quite a few things that you can still do with it, right? As I've already mentioned, you have this data where you can go ahead and put forth a particular color to a category, right? This might not be the best of visualizations, but if you go ahead and put forth a subcategory in size, so you don't have shapes here, size is what you have, so it will change that size for you as well. So if you just remove it, it should look a little different. So when you actually go ahead and have scatter plots with you, right, when you have something like this, so which is not best for this visualization that you have, for scatter plots, what you can do is you can go ahead and have different shapes that represent different set of values as well. So that is something that you can do with your you can basically go ahead and do that with your data in Tableau. So these are the options that you have here. You can choose and chop from some of these options. Let's see, I want a line graph. I can get a line graph if I want to. So even those are the options that you have, right? If you come here and you click on this thing, this is a different format of data that you have, and you can represent your data in this form as well if you want to. If I remove this now, you see, and now this data is fairly distributed. So I'm going to come here and say remove aggregation. You see, so this would be a better visual for you. So you get to choose these options, right? So again, your marks are based on the shape that you have, right? So in this case, if I just go ahead and pick up my sales here and put it in shape, you see it would represent shape for different subcategories differently. You see, so there are quite a few things that can be done with Tableau, and you can experiment or play around with your data in numerous ways, in different ways, and Tableau would actually let you go ahead and do that. Let us now go ahead and discuss some of the other things. Now we've talked about dashboards to some extent in the previous bit, where I explained what dashboards are and how do they work. Let us now go ahead and try and implement or create a dashboard. But to do that, I would be needing a couple of visualizations, but I think we have like 2 to 3 sheets, so that should be good enough. So let's go ahead and do that now. Okay, so we have this with us, we have this with us. It's more or less the same data, but we are just trying to get the gist out of it, as in what are the kinds of visualizations that you can create. Let's now go ahead and click on this plus icon again. I'm going to create one more visualization. This time what I'm going to do is I'm going to go ahead and pick up state, and I want profits state wise. So there you go. This is giving me profits based on different states. So I can actually go ahead and remove these categories from here. I don't want them to be here. Okay, so and I'm going to remove this again. That is why the visualization looked so different, right? Because there were certain things that were added here. I'm going to go ahead and again put in my sales here, and I'm going to put in my states here. You see the data is represented state wise here. So you can go ahead and choose again different colors for it, represent this data in different ways. If you want it to be in this format, you can actually go ahead and see the information here. Okay, so the darker the state, the more the sales it had. You see, this is one of the darkest one here. This is like 310. This is what, 457. This is 170. This is 138, and then you go down. These are lighter ones, right? Again, let's not get into the details of that, but the coloring here represents what thing do you need to focus on. If you just minimize this, you see there's a color bar here saying that the higher the value, the darker it gets, right? So do you want to edit a title? You can do that. Do you want to edit colors? You can do that as well. If you say edit title, you'd be getting an option here. What changes do you want to make here? And you can go ahead and just reset it if you want to. You can just close it and you can actually go ahead and do other things. So this is how these visualizations look like. Now again, each sheet here is giving you a separate visualization, right? Let's now go ahead and create a dashboard and see if we can pin some of these there on the dashboard. So we know the fundamentals of dashboards. Let's not get into the details of stuff, but let's explore how it works. I'm going to go ahead and click on this to start with. And what I'm going to do here is I'm going to go ahead and create a dashboard. So when you do that, you see you have an option here. You can do a device preview if you want. So this is how your preview would look like if you have that selected. You can go ahead and select different forms as well. So if you look it on phone, this is how your visualization would look, your dashboard would look if you do it. If you select default, this is how it looks like. In the layout too, you have an option, right? You can choose a default one. You can go ahead and play around with all these things in different ways, right? If I just go back, yeah, and if I come here and I add a dashboard again, this pane would be available for me to visualize my data. So again, you can choose the size of your desktop browser as well, right? You have the options here. You can choose different things. Where are you trying to embed this report? And based on that report or that dashboard or that size where you want to fit it, you can choose all the options here. Let it be by default a desktop browser size, right? And in that you can have different objects, you can add images, web pages, and even when you actually go ahead and put forth this particular thing, please note certain things how it works. So sheet 1, sheet 2 is this one. I'm going to pick up sheet 1 and drop it here. You see, this is basically a tiled view for your report. You can move it around here, but it is still a tiled view, right? It's not hovering around. So I can just close it here, right? And there's another form here saying floating. So when I click on floating, I can just put it here and the floating tile will move around. It would be easier for you to move around when you actually go ahead and create a visualization, right? So this is how this data would look like to you. Now, if you click on this icon, you see where we get redirected to. You see, we've come back to sheet number 2. Why? Because this is where this visual has been picked from. Okay. So if I again come back to dashboard 1, this is how it would look like. Now there are other things that we did not discuss in the theory part, that is creating a story. So in a story, basically again, you use different threads that you have in a dashboard and you can combine that to make a story as well. Stories and dashboards are a little different from each other. Let me show you how. Now you come here and you select this data and you put it here. Okay. So when you just come here, you see you might have certain options here. For the every sheet that you make, you have this data set here. You can add a filter if you want, right? So in the filter, what I'm gonna do is I'm gonna basically go ahead and filter out certain things. I'll tell you why am I doing this. So this is nothing but category wise sales, and I'm gonna add a filter here. So let's just go ahead and say okay, right? So you have a filter. I just want to come here and basically, okay, we cannot go ahead and do that functionality, the one that I wanted to show you. So let's just go ahead and go back to the dashboard here and let's just go ahead and yeah, so forget about those things. Basically when you go ahead and take a look at these visuals that you see in the story here, right? So there are quite a few things that you can do with this data as well, right? So when you talk about going ahead and playing around with these things, so if you add a filter to this particular category, right? If I select furniture as well, okay, so the furniture would reflect here, right? And if I do that, if I come to the story, again the furniture is reflected here, right? And let me just come back to the sheet now. Again, the sheet will have everything that was here, right? Now let's go back to the dashboard again, and this time let me say that I just want to have technology here, and I've added this filter here. So if I come to the story now, you see, you'll see only this particular thing that is reflecting here. You see, now we can, if we come back here and if you see the sheet, again the changes are reflected in the sheet. So whatever changes I make in the story or in the dashboard, those changes would be reflected back to the sheet that I've been working on. You see, this is one of the major things that happens when you talk about working with dashboards and reports. Now you might still wonder as in what is different here, right? Let's just go back here and say all of these categories, and let's come here. Now what I'm gonna do here is I'm gonna come here and look for an option called as filter. I don't get a filter here, do I? Okay, so if I do have a filter and if I make changes there, whatever changes happen in the story, okay, so whatever, see, I'm not getting an option to add a filter here. So, but let's assume that if I do go ahead and make some changes here in the filter, so what would happen is those changes won't be reflected back here. In the first place they would, but if I now go back and change this data here, and if I've made changes in the story, the changes that happen here will reflect in the dashboard, but not in the story. But right now, what I see here is if I make changes here, it will reflect there. Why is that? The reason the changes will reflect there is, you see the filter has been added here, has been added in the dashboard, has been added in the story. Now, let me show you with the example itself. So if I make changes here, you see, so I've basically gone ahead and changed this. You see, nothing is reflecting in the dashboard nor here, is it? But when we did make changes in the dashboard, that reflects in the sheet. So story is nothing but a surface level thing which you can create and show it to people, but that won't reflect back into your sheet or into your dashboard. But if I make changes in the dashboard, those would be reflected here. You see, it gets reflected here right away. But again, it's not getting reflected here. Why? Because I changed the story. If I again come here and I make changes here, if I go to sheet 2 and dashboard, yes, we had done the changes here, right? So let me just come here and let me play around a little. So here too, if I go ahead and select everything, now my sheet 2, it won't reflect, right? So whatever I make changes here in the story part, it won't get reflected in my sheet nor in the dashboard. But if it is vice versa here, if I make changes in the sheet or the dashboard, those will get reflected in the story only when the story has been unaltered, if you've not added any filter. So it is very important you understand this hierarchy here. How it works here is, let's assume that you have unaltered data. Okay, so when you have unaltered data, in that case, if you make changes, be it to sheet, those would reflect in your dashboard, report and stories. Okay, if you make changes to the story, they won't reflect in the sheet. They will not reflect in the sheet nor in the dashboard. Okay, and one important thing that you need to understand is, even if you make changes in dashboard, those would reflect in the sheet and in stories if the story is unaltered. But once you've altered the story, okay, so in that case, let's assume that this is your altered story where you've added filters to the story. Whatever changes you make in the story, those won't reflect in the sheet nor in the dashboard, and that is what we just saw. So this is how Tableau works, and when you talk about its features, the options are plenty. The ways in which you can actually go ahead and play around with your Tableau information is, there are multiple ways to do that, and you can do the same things in Power BI as well. We've talked about Power BI to some extent. The visualizations here are a little different. Here you can just go ahead and select a particular thing. What do we do here? Let's go to our standard measures. One is your profit, right? So I can drag and drop stuff here. You don't have the X and Y axis thing. You can have that here if you want to. And let's say that I want to find out sales as well. So I have my profits and sales. Okay, this is more of an histogram kind of a diagram that I have. Let's just go ahead and click on pie chart, and it will give me how much is the profit and how much is the sales, right? So you can go ahead and categorize your data like this here in Power BI as well. In Power BI, you have other options, other features. If you come here, you can select what kind of color do you want to add here. You can choose different colors. Let's assume that I want to use red puff. Okay, so profit should be green or blue. Let the sales be red. You see, you can choose different colors and play with the data in different ways or in different order. So you can do all these things in Power BI as well. There are plenty of options here. The interface is little different, right, than what you looked at. And if I were to go ahead and publish it, it would ask me for publishing. But right now, I have not logged into my Power BI services. So it might ask me to log in, which I do not want to. But let's call it a sample PBB file. Okay. And once I do that, it will save it. Enter your email address is what it says. So let's just enter a random email address. Let's see if it works. I don't think it will. Yeah, so let's not get into these details of logging into the account. I believe you get the idea. So once you publish it, it would get published somewhere and you'd be taken to the services platform. This is where you'll create your dashboards in Power BI, which is little different than how it works in Tableau. More or less, this is how, or this is what the gist is, and this is how Tableau and Power BI both work like. Let's just go ahead and look at some other things that we've missed out on, if we have, and see if there's anything that we need to look into. But this more or less is pretty clear. You see, you can add a caption here. You can name your story, say story 1. These are certain things that you can do here if you want to. And if you go back to the dashboard, there are other options that you can do. You can close this filter if you don't like it here, right? And you can actually go ahead and interact with the data that you have. You can see all the information would be here. Anytime if you feel that you want to go back from the report or story, you can always click here and you'd be redirected to this pane. And I believe by now we've fairly talked about a lot of things, right? This is where the data sources. So we've fairly talked about how you can go ahead and create a visualizations and stuff. If you want to play around with the data that you have, you can click on the data source option here and take a look at the data, as in what other things can you do with the data set that you have with you. So you can add certain things, right? I talked about the relationships. You can create a relationships here when you talk about Tableau. So this is it about how Tableau works and what all can you do with Tableau and what are some of the best practices that you can get involved in when you talk about Tableau. So I hope this demo is clear to you people. Now let us try and understand what is Power BI in little more detail. In the previous video of this course, we've already discussed the different data visualization tools. We also talked about Power BI to some extent. Let's try and understand Power BI as in what all can it do, what it is, and how does one define it. So when you take a look at the definition, Power BI is a tool which basically lets you control quite a few things, right? Be it from connection to collaboration, Power BI is the most powerful, secure, and flexible end-to-end analytics platform for your data. When you say an end-to-end platform, right from data consumption or data sourcing to the end process where you generate reports out of it, right? Power BI takes care of quite a lot of things. So when we are talking about data visualization tools, the primary function here is to take in your raw data and generate visualizations out of it, which can convey some of the missions or messages very effectively. And that is what Power BI does for you. It gives you end-to-end solution to quite a lot of problems that you may have in your hand. Okay. And that is what Power BI is in a nutshell. Let's try and understand Power BI a little more with the features that it offers. To start with, Power BI offers apt visualizations. So the number of options when it comes to visualizing your data are plenty. They are numerous, and you can actually go ahead and customize the visualizations and do a lot of things with it. As we get into the demo part, we'll be discussing these bits in a lot more detail, and all of a sudden these concepts like depth, automatic functions, connecting to data, apt visualizations will start making a lot more sense to you. But for now, let's try and understand what the definition or what do these pointers stand for. So when you say apt visualizations, the aim here is to generate visualizations that convey detailed or a lot more information for you with ease. You can get into the depth of concepts. So this is where your drill down features come into picture. How do you get into depth of information? Let's assume that there's a business problem for which you're reporting certain data and presenting it in the form of visuals. And that certain data is nothing but the sales on yearly basis. So what we realized was, let's assume that I quoted data for 4 years where I showed the profits or sales, whatever it is, right? Let's assume sales for last 3 to 4 years. Now, what we realized was this year there was a sudden spike, or there was a high increase in the sales that we did. So if I have to figure out, let's assume something like I want to understand in which part of the year did I get more sales. So I can actually go ahead and drill down and take a look at quarterly data for this year. I can compare it with quarterly data for previous years, and what that would tell me is, as in which quarter did we have more performance? Was it consistent? Was it a particular quarter that we got more information in? So when you say drill deeper or get into the depths of information, that is what you do here. Then you have something called as automatic functions. Now, what are automatic functions? Automatic functions are nothing but the ease with which you can actually go ahead and create visualizations where Power BI supports you by giving you ample and good suggestions for your data. If you are not certain as in for what visualization should I opt for when I choose this particular data, do not worry about it. All you have to do is put that data, and if that can be visualized, Power BI by default will suggest certain visualizations for you. Again, something that we'd be seeing as we perform demo and we get into the practical part of things for this course. The next point is connection to data. There are very less data sources out there in the market to which a tool like Power BI cannot connect to. So when you talk about Power BI, I don't think I've seen any tool yet or known any tool yet that you cannot import your data from into Power BI. Again, the different connection sources is something that we'll discuss as we move further. So this is what Power BI is in a nutshell, be it from connection to collaboration. It is an end-to-end analytics tool for your data. Okay. And apart from that, it provides features like it gives you up visualizations, in-depth drilling and understanding of your data. It lets you basically go ahead and use automatic functions, something that you can use to connect or basically you can use to create more better visualizations, and you can also connect to different data sources, making it easily available for different requirements. So when you talk about the Power BI architecture, we are not going to get into the complications of how the architecture works in detail, but there are 3 important pointers that you need to understand, and you can see those pointers at the right bottom corner of this slide, where we've talked about data integration, processing, and presentation of information. What that means is, when you talk about any data, the first step is to get your data from different sources. The next step is, once you have that data, you integrate it, you transform it into more edible data. And once the data is edible, you just present it in a better manner. So people who work in ETL can relate to this, right? Extract, transform, and load. That is what we do. So basically, when you talk about Power BI, it works no differently, right? One, as I've mentioned, there are very few data sources to which Power BI cannot connect to. So you'd be taking in data from different data sources, right? And then you would move it to Power BI services, which is their online platform. Now, once it is there in Power BI services, you can then through the gateway move it to the servers. It can be your private server or Power BI server. And if and when required, you can use tools like Power BI Desktop, okay, which can be used to basically go ahead and create visualizations using Power BI, or basically using this tool, you can create visualizations. So what are the sub tools that you can use? This is something we'll see as we move further. But this is how the architecture of Power BI works. I hope that is clear to you people. Let us now go ahead and understand the different components of Power BI. So when you talk about the different components of Power BI, we have quite a few components that Power BI offers to us. So to name a few, you have your Power Query, you have your Power View, you have your Power BI Q&A, Power Pivot. Then you have other features as well, right? Be it your mobile features, be it your desktop features, right? There are plenty of these out there in the market. Let's try and understand them one by one. Okay. So first and foremost, let's talk about Power Query. Now, Power Query is one of the important components of Power BI that can be included in your Excel, or it can also be used as a component of Power BI Desktop. Now, using Power Query, what you can do is you can basically delete your data from numerous data sources, or even extract your data from a wide range of different databases, be it your Oracle, SQL Server, be it MySQL, be it other databases as well, or different sources as well. What you can also do here is you can fetch data from records. Now, these records can be like your text files, CSVs, and even Excel files, right? So when you talk about Power BI, it gives you a feature of working with data, be it dealing with different data sources, be it deleting or fetching data. All these things can be done by using your Power BI query or Power Query. What Power BI also does is it gives you a strong GUI, that is graphical user interface, so that you can actually go ahead and transform a lot of your data and use this data as you need. Now, when you talk about transforming, you might require data such as date and time, changes, adding columns, changing the types of your data and content, right? And many other different options that are there on your plate. Now, when you talk about Power Query, again, it is useful as it uses formula like your M formula language. Power Query M formula language is what we call, and it is more vigorous than a normal GUI. So that is what your Power Query lets you do. It lets you deal with GUI requirements as well, and all the data processing that we discussed at the initial point of start. Now, let's try and understand the other components. I'm going to go through these components in random orders. So let's now discuss the Power Pivot, what it is and how does it function. So when you talk about Power Pivot again is a data modeling and calculation engine. It is used for modeling simple and complex data. In Power Pivot, you can set or create relationships between different tables and calculate values that can be viewed in Power Tables or pivot tables rather. Now, when you talk about it, what it does is it also gives you a lot of space where you can actually go ahead and create your designs. And another important thing is when you talk about Power Pivot, it uses DAX, that is data analysis expressions, something that we'll see to some extent as we move further. So it is a very strong concept when you talk about DAX, and it serves quite a lot of purposes in general. So we'll discuss that as we move further. The next point that we would be talking about now is your Power View. When you talk about Power View, again, it is a data visualization component, a basic one, a fundamental one though. And what it does is it is a component that lets you interact with the data and connect to different data sources that you have, just like you do in Power Query. But the other thing that it gives you here is you can retrieve the metadata that you have, okay? And it can be used for data analysis. Now, there are many blueprints for visualization in Power View lists, if you talk about it in general form. And with Power View, what you can also do is you can filter your data for every visualization component or for an entire report if you want to. You can add slicers to it, right? You can slice and dice your data. And when you talk about reports in Power View, these are interactive in nature and can highlight some important parts of the data or different components in Power View to interact with each other. Now, next you have on your plate is Power Map. Okay. So when you talk about Power Map is used to visualize geospatial data, which can be in 3D mode, right? So Power Map basically lets you deal with geographic data. Now, when you're talking about this data type, we are talking about data that is specific to a particular location, and you need separate kind of visualization for it. And when you talk about Power Map, it lets you get all this data in place and also let you render this data in 3D mode. So what that means is with Power Map, you can go ahead and attribute or assume one of the attributes and then actually go ahead and create different views, be it your heat maps and stuff like that. Okay. So when it comes to dealing with geographic data, you can always opt for something like a Power Map. Now, we've been going around and around talking about different visualizations and the ease with which you can actually go ahead and get your data. The important point here is we need to question the data that we have, right? Can we do that? When you have Power BI Q&A, you can definitely do that. It is nothing but a language motor. You can think of it as a language motor that basically lets you go through your data model and question it to get certain important answers. Okay. And when you talk about it, it helps you find solutions to quite important questions that are there, figure out certain hints related to the data, and then using which you can either create more visualizations or just understand the existing visualizations better. Apart from that, you have some tools that Power BI offers. Now, we've talked about the important components and all the 5 ones are covered, but then there are certain other parts to it, right? You have a Power BI desktop, a desktop related service or a software that you can install on your system. And once you do that, you can go ahead and create visualizations out of it. Then you have something called as Power BI website, to which you can go ahead and publish your reports and dashboards. And then you have Power BI mobile apps. Now, when you talk about mobile apps, these are important. One, you cannot make changes to your data, to your visualizations when on mobile. But let's assume that you're stuck somewhere and you need to take a look at the report that has been sent or a dashboard that has been shared. What do? If somebody shares it with you on your phone and you have Power BI, which has access to take a look at that particular dashboard or visual, you can do that using your Power BI mobile. So again, guys, there are other subparts, subcomponents, but these are the core ones. I believe by now the different components of Power BI are clear to you people. So what are the building blocks of Power BI? Now, this is another important concept, theoretical in nature, but very important when you talk about its practical applications, something that is going to help us carry out our demos for this course much better. So let's try and understand what are the building blocks of Power BI. Now, when you talk about Power BI, the major purpose of using Power BI is to generate effective visualizations. So when you talk about these effective visualizations, we are talking about some key concepts that concern visualizations. So what exactly is visualization? Let's try and understand that first. When you actually present your data in a visual form, say for example, you have certain set of information that can be represented by a pie chart or a bar graph. What it is, we'll understand these graphs and charts as we move further. But let's assume that you want to convey that information in that form. It would be easier for people to consume that information than the written information that we've discussed. And when you create a visual out of the information you have, we call it visualization. The other important point here is data sets. Now, to create visualizations, you'd be needing different data sets. Data sets can be in any form. We've already discussed different sources of data that Power BI supports, right? So understanding how the data looks like and how to get your data in is something that concerns your data sets bit here. Okay. And next, as we move further, we have some other bits that we can discuss and which are thoroughly or equally important, right? And those are your tiles, basically your reports and your dashboards. So let's try and understand them one by one. First in this list, we'll pick up what tiles are. So when you talk about tiles again is a flexible, movable visualization that you can pick up. You can put it in a report, you can put it in a dashboard, and that would convey a single set of information that concerns your requirement. And when you build on it and you create multiple such visualizations and tiles together, you put it in a report. Now, when you talk about a report is basically one or more pages of visualizations, graphics and texts that you can put together and convey a certain set of information. It is a little different than what a dashboard is. Whereas if you talk about dashboard in particular, it is nothing but basically conveying a lot of information on a single page. As we move further, we'll be classifying these two topics in detail. But let me quickly give you a quick overview of all these services again. So the first thing that you have on your plate is your data sets, right? Data sets is nothing but a different data sources from where you'll get your data. Next to it is creating visualizations out of the data that you have, and a single visualization would be known as a tile. If I basically go ahead and create multiple tiles or visualizations using the same data source, then it is called as a report. And when I have multiple reports with me, I can pick important pointers from each report and put it on a single canvas where I try to build a story it is called as a dashboard. So these are the components of Power BI, or the building blocks rather, not the components. These are the building blocks of Power BI. Let us now go ahead and discuss Power BI reports in little more detail. When you talk about Power BI reports, now Power BI reports are nothing but a multi-perspective view or information into a particular data set, right? With visualizations that represent different findings and insights from that data set. So we are referring to a single data set, as I mentioned. A report may be a single visualization, or it could be multiple pages of different visualizations. So here your data set is single. Please note that. Okay. In Power BI, you can create your reports and you can edit the data that is there in your reports. But when you publish it as a dashboard is where you can interact with the data, but it is difficult to change your data once it is published in the form of a report. Let's try and understand what dashboards are first. So when you talk about dashboards are basically concepts where you try to build a particular story. If we go with the definition, it is a single page, also known as a canvas, that uses visualizations to tell a particular story. It is limited to one page, and a point note is that a good dashboard contains only the important elements of that story. Enough of reading the definition that is there on the screen, which has a grammatical error right now. Let me explain this concept to you more practically. Let's assume that you work for a particular company and you work for X team. Let's assume a marketing team. Now, you could be reporting data, your personal data or your team's data. There's a possibility of that. How does that work? Let's assume that there's a manager in the company who basically handles a marketing team, and there are like 15 marketing guys. So there could be a possibility that on monthly basis, every marketing guy reports the data to the manager. So there would be like 12 guys, 15 guys who report their data having 15 reports. And then this is what my monthly report or weekly report would look like. So there would be 15 reports with the manager. A manager would consolidate that report into one major report that he has, where he talks about the entire marketing team, which has important information about every report that you have on a surface level. There could be hundreds of such teams, or maybe 10-15 teams in the company that serve different purposes. Let's assume that all these 15 teams have managers who create 15 individual reports for their teams. Now, if I talk about a stakeholder might not be interested in taking a look at those individual reports. What he wants is an insight as to what improved, what did not, and what we can do better. For that, what if we build a dashboard where we take in important pointers or the noticeable pointers that need to be noticed from each of these reports for individual teams, and put it on a canvas where we can build a story out of it. Say, for example, just because there were a lot of YouTube videos that were published on a particular channel, we saw a lot of traffic being generated for sales leads, and this is where the increase in sales happened. So we are passing on the information and trying to build a story by connecting the dots from different reports. And when you pick up this important information and build a story, we do that on a single canvas, and that canvas here is called as a dashboard. So I hope what a dashboard is clear to you people. Let us now go ahead and understand how to install Power BI and understand what its interface is. Once we do that, we can come back and cover some of the other concepts that would help us go ahead and demonstrate all that we've looked into. So let's do that. So dear attendees, this is how the Power BI desktop looks like. We'll talk about it at stretch, but before that, let me show you how to install Power BI. So to do that, open your Google or any browser that you have with you. There you go. So let's just go ahead and look for Power BI installation. Okay, and if you select it, it would redirect you to some of the suggestions, and you can just come here and look for this first one, powerbi.microsoft.com. So when you click on this downloads panel here or suggestion in the link, so you can basically see that you can download different Power BI tools that you have on your platter. Do you want a Power BI Microsoft Desktop, Power BI Mobile, the ones that we discussed, right? on-premise servers and stuff, you should actually go ahead and download your Power BI desktop version. So if you click on open Microsoft Store, it would take you to that particular place. So again, this is basically redirecting you to Microsoft stack of products available in their Play Store or in their local store. Okay, so this is where you can actually go ahead and download your Power BI desktop. You'd get an option of downloading here, but since I already have it downloaded on my system, it says launch. So if I click on launch, it would basically take me to the software that I've already installed. You can see the product is installed is what it says, because I have it on my system. You have all the information here and all the system requirements. I don't think there are any major system requirements. It's a very basic desktop tool. You see, these are the requirements it has. You need like 2 GB of memory, that is very low again. So you can download a Power BI version for that. Once you do that, guys, it's just click and launch kind of an action. So just continue clicking on it till it asks you to click on finish, and once you do that, you'll be having Power BI installed on your system. As simple as that. So make sure you do that. You download Power BI here. It is a free of cost tool when you use it on your desktop, and basically there are no premium features here. From a learner's perspective, this should be more than enough for you to go ahead and get started. So that is what Power BI desktop installation looks like. I'm not going to walk you through the installation process in detail. It's not complicated. Anybody can do it. And once you install, this is what you'd have on your plate. So this is how the interface of Power BI looks like. Let's quickly walk through some of the important pointers that are there on our plate. And once we understand how the interface looks like or works, we would go back and cover some of the important concepts, and then we would get into a full-fledged demo as to how to do these things practically. So what exactly is this interface useful for? First and foremost, you have these panes here. When you click on file, you see it would show you the reports that you've created. Now I've created plenty of those here. You can save those. You can even click on get data to basically connect to different data sources. You can import and export your existing files. You can publish it to the Power BI services, where you can have your reports created or your dashboards created rather, and you have other options as well. You can even click on get started to basically get information about Power BI. So let's not do that. Let's just go back for now. There's another option here, get data, you see. So this is where you can import data from different sources into your Power BI. So I'm gonna just go ahead and import certain set of information for now that can be used later on. So let's just go ahead and import an Excel file. I think I should be having an Excel data store. Yes, there's a data set with me here. Superstore is the name of the data set. And once I click on it, it should be able to import that data for me and show me how to actually go ahead and put this data in. So you see, the navigator understood that these are the different data sources that are there in the sheet that I just imported. I can just click on these things telling that, okay, import data from all these 3 files. I'm going to say load. You can transform the data if you want, but you can do that later as well. We are not going to do that because this is a fairly edited sheet that we have with us. And just like that, guys, our data would be imported. You see, there's orders, there's people, and there's returns. So it would be importing data from all these 3 aspects or all these 3 features that we have on our plate. Has imported? Yes, the data has been imported. You see it on the right hand side, and you get all the categories of data that has been imported. Now, in case of Tableau 2, you have a very similar interface. The fact that we are talking about different data visualization tools, let us go ahead and look for Tableau as well. So I'll show you their interface as well. How does Tableau works? Okay. So meanwhile it opens, let's continue talking about it. So these are the different sources through which you can import data. You see the summation sign here. The summation sign indicates it's a function that you are using here to calculate these values, or a measure rather. Apart from that, these are your data that is more dimensional in nature. And if you come down here, this is more quantitative or measure kind of a data when you talk about profit, be it a discount, right? Your quantity, your sales. So this is more of a quantitative data. Here you see your different visualizations that you can use, something that we'll discuss as we get into the details of things, right? So you can also import your data, right, from different sources. If I click on get data, you'll see that there's so many data sources here. I mentioned that there would be very few data sources to which Power BI cannot connect to, and I'm very sure about it. You see, you can connect to all these data sources that are there with you, and these are plenty of data sources. I'm sure there would be very few organizations that use anything apart from these data sources. So you can go ahead and choose your data from all these data sources. You can basically go ahead and work around with other sources as well, right? If you come here, you see you have options of data modeling. So basically you can go ahead and do quite a few other things here, right? If you need a new measure, you can do that. So when you click on new measure, basically you're talking about running your DAX queries, something that we'll see as we move further. Okay. Apart from that, if you click on view, you can basically add filters, bookmarks, and also analyze some of the performances that is there. So the options when you talk about Power BI is plenty. If you just want to go ahead and take a look at your data in plain hindsight, click here. So this is where you'll be creating all your visualizations. This is where you'll see all your data. You can again go ahead and arrange your data in different ways, different forms, different formats. So you have the basically support to take care of all these things here. Say, why do I not see my data here? Come here, go to modeling, and is it because we've opened a particular pane here? No need to worry about it. As we go ahead, you see there's a lot of data here, it's just not visible. So I'm gonna say sort it in descending order, and then we'll see, yeah, there you go, everything is here. So it was hidden for some reason. So when I did go ahead and change this, you can add filters here, right? Whether you want to sort your data in ascending order, descending order, do you want to sort it, do you want to clear certain set of information or run certain functions? So when you do go ahead and run DAX queries on it, you can do quite a few things with it. But that is a discussion for the later half. For now, let's just go ahead and understand how the interface looks like, right? This is where you can actually go ahead and create relationships. Now we have 3 tables. You can create a relationship between them. If they are not related, you can relate them in a way that you feel would make it easier for you to process your data. At the bottom here, you have different panes. If I click here, you'll see there's a page thing here. So you can add multiple pages where you can create different visualizations. Now let's go back to the the Tableau thing. This is how the Tableau interface looks like. You can connect to different data sources here. Okay. And once you do that, and if you come down here and you click on simple sample data superstore, which is a data set that Tableau supports, or it is an inbuilt data set, you would see Tableau's interface. Now in case of Tableau 2, you see there are and once you import the data, you see all these here. In case of Power BI, we had it on the right hand side, and this is where you'll have all the visuals like Power BI, you see. So again, we'll understand how Tableau interface also works. In case of Tableau, if you want to create dashboards and reports, you have the option for it, the story option, dashboard option, and report option here and here. In case of Power BI, that is little different. So this is about the different interfaces for both Tableau and Power BI. That's it for the interface part. Let us now go ahead and try and understand what Power BI DAX is. So when we talk about Power BI DAX stands for Data Analysis Expressions, which again is nothing but a collection of functions, operators, and constants. It is used in formulae, and basically it returns one or more variables. It is a native formula and a query language by Microsoft. Now this is what the definition has to say. Let me, however, simplify the whole data here, the whole definition for you. In simple words, DAX or data analysis queries are nothing but these are a process where you can create functions, right? Or basically you can create sub functions using which you can generate certain values. Say for example, you are talking about certain data set where you have maybe categories with you. Now you want to count the number of categories that are there. So you can create a separate function called as count, and you can add that as a measure in your table values, so that next time when you look for the count, you have that as a column name with you. Now, why do you need this to start with? Even when you have all this data filtering and all the processing with you, if you have something like DAX, you can always on the fly add custom functions, custom measures to your data. As we get into the demo part, we would understand how to go ahead and set this in process. But before that, let's quickly understand some of the pointers that are here. To start with, DAX is a functional query language. So you can basically create certain functions and basically bring out certain functions that you want to generate results. It deals with relational data. Yes, obviously, if you talk about something like Power BI, you're mostly concerned with relational data, not mostly, always concerned with relational data, and it helps you perform aggregations. This is something we'll see as we get into the demo part. Next, let us go ahead and understand what are the components of Power BI DAX. So when you talk about DAX in general, DAX has three components. One is the syntax, the other one is the function, and the third one is the context. Now, when you talk about a function is nothing but a formula, something like sum, something like count, right? So that is a function. Syntax, what is a syntax? Syntax is nothing but grammar to implement something, right? When you talk about syntax for English language, grammar for English language, it is nothing but how you form a sentence, right? In mathematics, syntax can be creating mathematical functions, mathematical formulae that would give you result. Just like in programming, we have syntax that is used to basically convey a particular action, right? Similarly, when you talk about Power BI, we are talking about mathematical calculations here, aggregations here. And for that, you'd be needing some grammar, some syntax. And this is what the component syntax of Power BI gives you. Next, you have context. Now, context is the ability to create functions, right? So if you are dealing with basically adding or working with row values, this context would be called as row context. Similarly, if you are adding a filter either to a column or even to a row or to the entire data, then it is called as a filter context. So basically you have two contexts here, that is your filter context and your row context. Similarly, you have functions and syntax in Power BI DAX. Let us now go ahead and move into the Power BI console and try and understand how DAX functions can be created or how do they work. We would be going ahead and creating quite a lot of visualizations, but that is for the later bit. For now, let's try and understand how Power BI DAX works and what all can you do with Power BI DAX. So to do that, let's assume that we have quite a few measures here, quite a few stuff that we can work around with. So here's a column name called as subcategory. Let's try and write a DAX query for it or a function for it that gives you the count of the subcategories that we have with us. So if we come here in the data source, you'd get to know that we would be having this category of sub data somewhere, right? This is what we have here. Let's assume that I want to count all these categories. Now, fortunately for us, we can keep a track of it. If I scroll down, you would see that there are 9994 rows. So our count should be around that, right? If we create a count function for or a count measure for this particular subcategory. So what I'm going to do now is I'm going to test if the hypothesis is correct. If I create a count function that basically gives me a count of the total rows under a subcategory, can we do that? Yes. How do we do that? I come here, I right click and I say new measure. And what is the measure that I'm going to create? Let's call it subcategory count. Okay, so as you can see, Power BI is smart enough to give you suggestions where it would suggest certain things to you, basically operate with, so that your functioning becomes easier. Let's see how does that work. If I come here, okay, and now I want to count it, right? So all I have to do is I have to just type COU maybe, right? So it will suggest the possible functions. If I had to do sum, I would have typed sum, right? It would have given me that. So again, it is suggestive, this interface, where if you put in certain values, it would suggest a solution for it. Now let us go ahead and look for count and select count. There you go. And it would open the syntax for you. What it suggests is enter the column name for which you want to count, right? Let's say subcategory. You see, so the orders table has subcategory. I'm just going to go ahead and enter it here and I'm going to hit the enter button. And once I do that, the category gets added here. You see? So if I come here and drop it here, you see it creates a bar graph for me. Okay, we'll understand all these graphs and stuff, but I want to check whether the count is correct or not. So there's a visualization Power BI called as card visualization. You see, it gives you this number, suggesting that there are these many subscribers, and that is the, not subscribers, subcategory count. And that is the count that we saw here at the bottom, isn't it? 9994. So it is giving us right and exact values that meet our requirements, isn't it? I'm going to remove this for now, and I'm going to remove this from here as well. So the subcategory count thing, I want to delete it. I do not want it here. I'm going to just delete it. Yes. So this is how your DAX basically works like. Okay. I hope that is clear to you people. Now let us get into the final bit of this course and let us try and understand visual analytics. Visual analytics is nothing but the ability to use visualization to convey information better. So this is where we are going to get into the details, into the demo of Power BI. We will explore Power BI to the core, and at the same time we would understand different visualizations that are there with us. So let us just go ahead or go back to our Power BI console and see how we can do all these things. So I've gone ahead and I've opened up the Power BI console. Let's try and understand this console. So I've actually given you an explanation as to what this interface does and how it looks like. Now we are going to go ahead and drill down into it from more of visual analytics perspective. But for us to understand this better, let us try and understand the different visualizations that we have with us, or what are the popular visualizations, charts and graphs that we know of. So let me quickly explain those to you. Okay, let's do that. So talking about the types of visuals or charts we can create or we can think of. Now there are plenty of those. I mean, there are 40s, 50s, hundreds of these. So we'll discuss the basic ones and the important ones that are centric to all the other charts. So the very first chart that should come to your mind is bar graph or a bar chart. This is something that is very popularly used as many statisticians. This is something that we learn in schools as well, right? A bar graph is more of a graph that gives the information about two values and how do they work around each other. Let me quickly define this for you to start with, and then we can go ahead and see this in the visualization part as well. So when you talk about bar graphs, it is the simplest and the most straightforward way to compare various categories in the classic graph. It is one of the most recognized visualizations, graphs or charts out there. When you talk about bar graphs, they are very popular or known for visually presenting nearly any type of data. In particular, we are talking about if you want to compare multiple variables, this would be a good option to do that. And to give you an example, let's come here. Let's just go ahead and create a sample visualization. Again, guys, I'll be talking about quite a few pointers. Do not engage yourself into this, as in if you feel that this interface is new, but we'll get into the details of it. See, this is a bar graph, right? What you see here. So this is how you create a bar graph. How do we get into the details of it? This is something we'll discuss once we are done with talking about all the graphs that are there with us. Now, let us go back to the sheet and talk about the next one. Then is the pie chart. So when you talk about the pie chart or pie graph, it's not a graph, it's a chart basically. Pie chart is nothing but a circular graph or a visualization that you can think of. And when you talk about this, this is how a pie chart looks like. But the fact that there's only one value here, it would look a little different. So let's just put in categories here, and this is what a pie chart looks like. So basically you're talking about a particular entity. If divided into multiple parts or into subcategories, how would that entity look like? When you're looking for this sort of information, this graph is called as your pie chart. And again, if I remove this, there is third thing on our list, which is a line graph or a line chart. Let's call it line graph. Line graphs are something that are very important when you talk about comparing two variables in real time or in time format. To give you an idea, let's assume that you have order date with you and you want to calculate profit, and you create a line graph. See, this is something that would give you value for two variables in varying time. So that is what a line graph does for you. Again, I'm covering these things quickly because I want to discuss other pointers as we get into the details of data visualization, but these are the basics that should also be clear to you people. So I'm just walking you through those pointers. And then you have your histograms. Now histograms are nothing but continuous bar graphs that basically show values for basically continuous values that are broken down in intervals. Like let's assume that you want to draw a graph for values between 10 to 20. Similarly, 20 to 30 is another graph. So you'll be having a bar graph that is connected to each other, maybe 10, 15 graphs or bars that are connected to each other. That kind of diagram is called as a histogram. So these are some of the popular graphs that people use. The other one are your geographic graphs or geospatial graphs. These are something that are used to convey information based on the location. Something that we'll see as we get into the visual analytics part, which we are going to do right away. So let's just go back and now try and understand how Power BI works and what all can we do with Power BI. So all the formalities, all the basics that are required have been covered. Now let us try and understand how can we create visualization using Power BI. Now all this while we've talked about all the concepts that are important for you to get started with this demo. Let's just go ahead and try and implement those things one by one. In the previous demo where I talked about the interface, we've actually gone ahead and see how we can basically import data and how the data looks like, as you can see here. So we are still with the Superstore dataset that was there with us. Now what we are going to do here is we are going to go ahead and continue our visualization from there. So there are certain things about the interface that we might have not discussed here yet. That is, how do we create visualizations in Power BI? Now there are plenty of options for you to do that. One is you can either double click on the column name that you have. The other thing is you can first select a visualization like this, and you can put in values there, or you can first select values here and then choose a visualization to meet your needs. By default, Power BI will suggest certain visualizations which it feels is best to represent a particular set of information. So you can choose both the options if you want to. Let's try and do the visualization process and see how does it go or how does it work for us. So to start with, first let's try and visualize certain data. What I'm going to do is I'm going to pick up order date. Okay, and while I do that, I'm gonna go ahead and put in my profits. You see, so it gives me profits for n number of years that are there. With Power BI, you can right away adjust all the profit and stuff that you want here itself. All your graphs can be resized to meet your needs, and you can actually go ahead and look into the values the way you want to. Now, what you see here is you see profits for the following years, right? It's what, 13, 14, 15, 16, right? So it's fairly old data, but it doesn't matter. It is for the demo purpose, so we should not be putting in too much thoughts into these things. How do we go about this drilling down process here? I had given you an example in the theory part where I mentioned that you can drill down into your data. Now let's assume that you want to take a look at the data by drilling down. Can we drill down? Yes. So let me click here. So we should have gotten values. Yeah, there you go. So it has drilled down now, and you see the data is there as per the quarters that we have, right? So it is Q1, Q2, Q3, Q4. So the data here is now divided into quarters if I want. If I go back, it would give me yearly data. And if I click on this, it would give me quarterly and yearly data both. The final one. So it is merging all the views that are there. So you see Q1, Q2, Q3 for 2013, similarly for 14, right? And this is how it looks like. In Power BI, you can actually have marked labels as well. If you want to take a look at values, you can just hover on it and you'll get the value. If you click on this particular thing, it will give you, okay, I actually accidentally clicked somewhere else. So it has just changed the axis for the data. something that I do not want. So I'm going to remove it from here for now. I'm going to just go back and put in the data again. So order date is what I have, and I have the profit here with me, isn't it? Now, if I just come here and if I just put this information in a corner, let's try and create some other visualizations as well. I'm going to go ahead and pick this visualization, and I'm going to show you how Power BI functions. So now I'm going to just expand this information, whatever it is here. I want a bigger chart for this. And again, let me just go ahead and put in profit. And let's see if we can put in something else. What is the other thing that we can put in? Let's put in sales. You see, for the total sales, the profit that we had was limited. And if I click on the profit that I want to see, it's represented by this. If I click here, this is what I'll get. But this is not one of the best visualizations that I would want. Let's just come here and put in order date here. Now, if I click on this particular thing, it would highlight that particular graph in the other visualization that I have. So you can do that as well, right? Let's assume that you want to find out profit based on the subcategory that you have. So I'm going to remove the order date for now, and I'm going to come ahead and pick my subcategory option here. I can drag and drop it and it will still represent the same information to me. Now, let's just go ahead and click on this particular value. You see, so what this suggests is copiers had this much amount of profit, and for every year this is the amount. So there was a rise in copiers profit, and it was a fairly good amount of rise. If I come here and if I click on it, the profit is 49543, right? If I come here, it is 61618. This year it is 81726, and this particular year it is 93507. So basically, if I compare it with this value, the profit has almost doubled, right? So this is how you can actually go ahead and track your data in numerous ways by using Power BI. Again, let's assume that you want to play around with the colors that you have. You can do that. In the axis, you can again play around with a lot of stuff. We'll drill down further, but for now, let's just come here and let's play with the data colors. Can I change colors? Let's assume that I want to have a different color for my graphs. If I select this and I just change a color here, let's say I want it pink. So all of this will change or have a different color, and you see all of it is reflecting here. Apart from that, if you want to do other things, you can actually go ahead and play around with it. Do you want borders here? Do you want backgrounds? Do you want to add images in background? You can do that. Why do we need to add images in the background? What purpose does that serve for me? Let's assume that I use images in the background. In that case, the benefit that I get out of adding those images in the background is, let's assume that I'm putting forth a report for a particular company. Let's assume that I want to have a logo there of that company. I can do that. Let's assume I'm creating an IPL dashboard. So in that, if I add a background of IPL trophy or maybe IPL teams together and I make it little less, I reduce its transparency. In that case, whatever is on top, that would get highlighted, yet having a plain background about IPL in the back. So you can actually go ahead and do all these things here, right? So this is how you go ahead and create visualizations in Power BI. Let us come ahead, or in the next page rather, and create other kinds of visualizations that we can think of. So let me just go ahead and use this. This is a geographic graph, and since it is a geographic graph, I'm going to go ahead and put in profit here. So this will take time to load because it's a geographic graph. At times it consumes more time than expected. And let's just talk about profits state-wise. Are we getting any information here? Yeah, there you go. So there's some information here. And this is not again the best of visualizations that you could have used. Let's see if we can reflect any information here, right? For that, I'm going to go ahead and put in my sales. Okay, again, not the best of visuals. So let's just uncheck all of this information that we have with us, right? And I'm going to just go ahead and remove this for now. The reason I'm doing that is I'll tell you. let's assume you put in states here. Okay, you see it is giving you information about different states that are there. So these are the different states. Now let us come here and add certain values. If I add states to the legend, it will give different colors to it. If I add it latitude, again there should not be any change here, but instead let's just go ahead and add profit. Now let's see if we get any profit here. We won't. Yeah, it's there. So basically you see New York is the one that had good amount of chunk of profit, right? Similarly here California also has good amount of profit. What this suggests is two of the major states in the country had a surplus amount of profit, and it is understandable. These are the bigger states or the more industrious states of the country. So basically again you can create visualizations depending upon how do you want to deal with it, right? Let's assume that I come back to my previous table or sheet, and here I put in this thing. This is a card value. So if I click on the card value and if I put in my profit here, it will give me profit, right? So this is the profit we had in total. Okay, let's assume that I want to filter it. Can I do that? Yes. So what are the filter conditions that we can have here? Okay, we cannot apply filter condition to this. Maybe to this we can. Let's try and filter it out. So whatever is the profit, which is, let's assume the maximum profit here right now is 44.52, right? So let's put forth details saying that whatever is the profit that is below 30,000. Okay, not a great filter. We'll add filters later. But I hope the idea or the gist is clear to you. And when you talk about a card image, it will give you values based on the other visualizations that you have. So you can always have highlighters added here or there, and this is how the visualizations look like when you create visualizations using Power BI. So we've seen a line chart before, we've seen a pie chart now, we've seen a bar graph as well. So this is how you actually go ahead and create visualizations, and there are plenty of options here for you to choose from. If you want global information, you can come here and just click on this globe, and you can have information represented globally as well if you want to. So if you put forth the state here, you'll have global representation of the information that we just did. So you can use these, you can use these if you want. So it depends upon your usage. What are you trying to use and how are you trying to play around with the data? And there are plenty of things that you can look into, right? But when you create a report, right? So you've created a report here, you can publish it. Let's try and do that. Let's save this report as demo report or GLA. Let's just say save. Now it would ask me, do you want to open it or where do you want to save it to start with? Save it in my workspace. For this, you would be needing your email ID. So make sure you have one. So publishing it to Power BI. So it would put it on Power BI server when it gets published. So this is where you would be needing internet connections as well. So when you click on it, it should open that report for you. There you go. This is the report that we created. Now, since it is published, you cannot just come here and do whatever changes you want to. You can interact with it, but not go ahead and make changes here. Now, this is a report, but I want to publish it to a dashboard. So in a dashboard, you are going to go ahead and put in certain visuals that you have, right? So we discussed what dashboards are. Dashboards are nothing but a single canvas where you can take in data from different reports as well. So to give you a context, you see there would be quite a few reports that I have created till time. So let me just see if there are reports here in my workspace. There you go. So these are some older dashboards that are there with me, and these are multiple reports that I have with me. So what I'm gonna do now is I'm gonna try and create a dashboard where I'll pick in some random reports and from those reports I'll pick up some random visualizations, that I would add to one canvas to one dashboard. So let's pick one. Demo report GL is the first one that we've created, right? Today. So let's just click on this and let's say I want this graph. So I'm going to select it and I'm going to say pin it to a dashboard. What is the dashboard? I'll just create a new one. Let's call it GLA Power BI and I'm going to say pin it here. Do you want to go to the dashboard? Please do that. You see, there's this visualization, and again, now you cannot act on it. Okay, you cannot make changes to it, but you can go back to the report from where it was created. How? You click here and it would take you back to the report, right? So I'm going to go back again to my workspace and here I'm going to go to the report. This time I'm going to pick up a random report. Let's say report 1. And I'm going to go ahead and pick up this pie chart. I'm going to say pin where? To the dashboard. Which one? GLA Power BI. So if I go, it says, do you want to create a phone view? If you create a phone view, you can send these on your mobile app and you can view it there as well. Okay. So this is how you do it. The icon went away though. So I'm going to go back to the reports in the workspace. I'm going to go to the dashboards that I have and GLA Power BI is what I'm going to open. You see, I picked up another visual from another report, and now in this report we have two different visuals with us, right? So this is how you actually go ahead and create reports in Power BI, or dashboards rather, not reports, these are dashboards. So this is how you create dashboards in Power BI, right? And in Power BI you can also go ahead and ask questions to the data that you have. Okay, so let's assume that I'm in Q&A and I'm going to check. If I come back here, you see this is profit that we have. I'm going to ask a question. 2014. Okay, so it's opening table for me. I don't want that. I just want the profit. It says blank. That is not possible. Let's just go back here and check. My profit in 2014 was 61618. So let's just say profit. Okay, this is irritating, but let's try this. $2014. It's 62.88k. There you go. So it's near about that. I'm not sure why is it giving a different value, but it's near about that, right? So this is how you can ask questions to your Power BI data that you have, and you can do numerous things with it. Similarly, if I go back to the Tableau interface, I told you that we can visualize data here as well. In Tableau too, the interface is fairly similar, right? You can just double click on a particular value and you'd get information about that. Say for example, I just double clicked on order data. So yes, we have the order date now, and now I'm going to go ahead and close this for now. Remove. Okay, next what I'm going to do is I'm going to go ahead and pick up sales, one of the easiest data to deal with, right? Sales. So it will give me sales based on the year, you see, and by default it suggests a line graph suggesting that you would be calculating sales for a particular year. And since it is values that are changing in time, you can have sales for multiple years represented by a line graph. A Tableau also suggests certain things on the fly. If you have one visualization like this, you can actually go ahead and put it on a dashboard. And for that, you have to just click here, and that sheet where you created all the information, that would be available here. In Tableau, you have options of tiled and floating visuals as well. So if I want to add it here, if I choose floating, I can just go ahead and add it here and it floats around. See, let's assume that I make it tiled. This one will move, but if I add a new sheet, it won't move around in this case. So let me remove this. Let me show you. You see, it's not possible for you to move it. It's consumed the whole space. You can maybe minimize it, but not move it around, right? So this is how Tableau works for you, right? But we are mostly focusing on Power BI right now. So let's just close the Tableau thing and come to Power BI. So this is how you create different visualizations in Power BI. And these are the different things that you can do with Power BI at stretch, at length. I hope that you've understood all these details as in how Power BI works, what all can you do with it, what are the types of visualizations that you can have in Power BI, and how to play around with all the data that you have. So you can keep experimenting and keep trying, keep creating more visualizations. There are a lot of things that you can work around in Power BI.
Now let us very quickly summarize today's video. In today's video, we discussed about the introduction to data visualization using Python libraries with demo on how to use Matplotlib, Seaborn and Plotly, Tableau and PowerBi data visualization tool. We also discussed about Tableau and Power BI data visualization tool. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.